Hello everyone, welcome back to Mathematics. So for today's video, we are focusing on this year's trial paper for Sabah paper 1. And compared to the last year's Sabah paper 1, I would say it's slightly easier. But of course, this paper has its own difficult and easy questions lah. Alright, so for this year, I tried to do something different, which is to add these unique labels which you will see when we are discussing the questions, right? So why I put this label is because these questions, I would say, is more complex, and also it appears more often in the SPM trial paper compared to our exercises that we do all the time, for example from the textbook or our exercise books. Right, so to put this label is to ensure everyone can put more focus onto those questions, so when SPM comes out a similar question, we can solve it effectively and to score full marks from there. Okay, so without further ado, let's go through the paper together. Our first question coming from the Indices, Surds and the Logarithms chapter, and here we have a logarithm equation. Okay, so to solve any kind of logarithm question, we are going to use the 3-step method to solve it. Alright, so the first step is base. Okay, so base here refers to these values. Okay, so these values, which is a 3 here, are the base values of the log. Alright, so the first step here is actually to change all the base values to be the same value. So if you see closely to all of the base values here, which is in red, you can see that all of the base values are the same, right? So if it's the same, then we can just skip the first step and we go to the second one, right? Because all of the base values are the same. So let's say the base value is not the same. So what should we do? Okay, so let's say I give you an example, right? Let's say I use this one, right? Log base 3, 2, right? So let's say my base, I want to change from 3 to 2. Okay, so how do we do that? Right, so very easy. So the first thing is, what we are going to do is to make a fraction first, right? And above and below, we'll be adding log. And for the value above here, we are going to take the value from this log, okay, which is 2. And the old base here, which is a 3, I'm going to put at the bottom. Alright, but how about the base value, the new base value for these two logs? Okay, so this depends on which base we are trying to change, which is 2, right? Okay, so I'm just going to put the 2 here. Alright, so this is how we change from base 3 to base 2. Alright, so now the second step is to manipulate. So means that we are going to use these formulas to simplify all of these logs even further. Okay, and to find the value of x. Okay, but firstly, let us move all these logs which are on the right side to the left first. So it will look something like this. Okay, so for the values which are positive, once we move to the other side, it will become negative. And for the negative values, if we move to the other side, it will be a positive value. Alright, so now we see that all of these logs are on the same side, then we can simplify them by combining them into one simple log. Right, so how do we do that? Right, so if you see the things which are separating these logs are the minus, right, minus here, and the plus here. Okay, so let's go to the formulas to see whether there is plus or minus here. Okay, so there is formula 5 and formula 6, right? This is the plus and this is the minus. So if you want to see if we have plus and minus, how do we combine them? We can look at the left side. So let's focus on the log that has the value n. Okay, so if you see in front, there is this plus. Okay, so if there's plus here, what we are going to do is we are going to multiply the log values. Alright, so m and n, I multiply them together when there is plus. What if it's minus? So it's minus, you see that the n here moves to the bottom, or meaning we need to divide. M divided by n. So this means if you see plus in front, then we need to multiply. If you see minus in front, we need to divide. Okay, so coming back here, for the logs in front, which is having a plus or positive, right, we are going to put on top because we are multiplying, right? And for those logs which have minus or is a negative value, then we should put it at the bottom because we are dividing it. Okay, so again, plus means we need to multiply, put on top. For those which have minus, we are going to put it at the bottom because we divide. Okay, so for the first log, this is a positive value, meaning in front there's a plus. Right, let me change my color of the pen. Right, plus. So this x minus 2, we are going to put it on top. Alright, and then here, the second log, we have a negative value or a minus here. So means divide, which means we are going to put it at the bottom. Right, same goes to x squared as well. And the last log here is a positive value. So 3x plus 4, we are going to put it on top. Alright, so we have successfully combined all of these logs to become one log. Okay, so if you want to simplify further, of course we need to cross multiply the things on the numerator and then multiply the denominator, right? So if you imagine we multiplied already, what else can we simplify? What else can we do to find the value of x? Okay, so this is the third step. So the third step is to change the form from the logarithm format to the index format. Okay, so what we see now here is the logarithm format, right? Because log, right, both have log, and the value of a here is 3, the value of y here is this thing, and the value of x is 0. So now we are at the logarithm format. So now we need to change to the index format, which is very easy to do. So you see the a here, right, the base value of the log, we are going to push it to the other side, right? Push the a to the other side. So once you change to index form, it will be y equals to a, right? You see the base, it is on the right side already. A and then power of x. Right? So coming back here, same thing as well. This 3, I'm going to push it to the other side. Right? 3 push it to the other side. So on the right side, it will be 3 to the power of 0. Right? Very simple. We just push the base value to the other side. Okay? So here, if you want to simplify, again, we need to cross multiply. So x multiplied with 3x, x multiplied with 4, negative 2 multiplied with 3x, negative 2 multiplied with 4. Okay, so above will be something like this, and the denominator here 2 times x squared. So here is 2x squared. Alright, so this is the 3-step method to solve any kind of logarithm question. Alright, so change the base, manipulate, and then to change the form. Alright, so now let us simplify this equation to find the value of x. Okay, so if you type this into your calculator, 3 to the power of 0, it is actually 1. Alright, so since here it's 1, then I can move this 2x squared to the other side, or meaning multiply with 1. So on the right side, it will be 2x squared. Okay, and then on the left side, this 2 plus 4x and minus 6x can be simplified, so it becomes negative 2x. Okay, and then I'm going to move everything to the left side again. So the 2x squared, I'm going to minus with 3x squared. So here we will be just x squared only. Alright, so now you see that this is actually a quadratic equation. Okay, so if you want to solve this, we can use factorization by using the calculator to find out the two values of x, right? So the two values of x would be x equals to 4 and x equals to negative 2. And with that, we have found our answer. But before we go to the next question, I think this is something where students will make a mistake, which is they already have the x values, but they forgot to check whether the x values is valid in the question or not. Okay, especially for equations that have logarithms, and especially where the answers are negative. Okay, so why do I say we need to take note on questions that have logarithms and answers that has negative? Okay, so if we recall back logarithms, right, the logarithms, let's say we have logarithm base 10, and let's say we have a x value, which is the value of the log. Alright, so if the x value here is a positive value or a 0 value, so once we put this into a calculator, we can find out an answer, right? So for example, log base 10, this would be equal to 1 if you put inside a calculator, right? Because the base value and the value here is the same. Okay, so it will be 1. Another case will be x is negative. So in logarithms, when x is negative, if you put into a calculator, let's say log base 10 minus 2, you will see that you will get an error, which means no answer, right? Because logarithms in law, they cannot be negative. So to check whether our x values are valid or not, then we can substitute these two x values into one of the logarithms here to see whether it will produce a negative value or not. Alright, so from all these 4 logs, I will prefer students to use this one, okay, because it's minus. So if we substitute these two x values inside, so we can see more likely which x value will produce a negative value. Okay, so let us substitute it one by one. Alright, so let's start off with x equals to 4. So when I substitute x equals to 4 inside this bracket, the result will be log base 3 4 minus 2, which is 2. Okay, so since this is a positive value, then we have an answer, which means x equals to 4 is a valid answer. Alright, how about where x equals to minus 2? Right, so once we substitute inside, so here will become log base 3 minus 2 minus 2. So here would be log base 3 minus 4. Okay, so this is a negative value. So again, recap, if x is a negative value, which means there wouldn't be any answers. Alright, so means that we need to reject where x equals to negative 2. Again, because for logarithm values, it cannot be negative. That's why we reject. Next question, going into circular measure. So in this paragraph, there's a few information. So let me explain it through this diagram below. Right? So the first information is we have a circular shaped garden, which is this circle with a center O, and its radius is 30 meters. Okay, which means that the line OC and the line OA, which are the radius of the circle, both of them are 30 meters. Right? And the next information is this owner wants to plant the flowers onto this shaded region, right? Which is the region APRC. Okay, so this plant will be planted with flowers. And for the next information is this minor sector OAC will be installed with tiles. Alright, so what is minor sector? Okay, so if you see the circle here, it is split by 2 parts, right? So each of these parts, they have their own names, right? have their own names. So the small part here, it's called the minor sector, right? Minor means smaller, and for the bigger part here, it is called the major sector, right? Major means bigger. So this minor sector OAC would be this part here, and will be installed with tiles. Okay, so before we move on, I would like to explain these two words. So one is called sector and the other word is called segment, which I think a lot of students will confuse what is called sector, right? Sector and segment. Okay, so these two are quite different. So let me explain the details now. So sector would be the parts of the circle that involves the center of the circle, right? Which is something like this. So this is called a sector of a circle. So segment, right? So segment does not involve the center of the circle. So means it does not connect with the center of the circle. For example, something like this. So this is called a segment. It does not involve or include the center of the circle. Okay, so this is the main difference between sector and segment. Sector includes the center of the circle. Segment does not include the center of the circle. Alright, so coming back to here, we are also given the ratio of line OAP. Okay, so OA is 3 parts and AP is 1 part. So going into part A, we are given the perimeter of the tiles, which is the minor sector here. Alright, and we need to figure out the minor angle. Alright, minor angle of sector OAC. Okay, so since this part is called the minor sector, so its angle, which is here, which is the theta here, it's called the minor angle. Alright, and we need to find out this minor angle in radians. So since we are given the perimeter of the tiles area, so why not we form an equation based on this perimeter to find out the minor angle. Okay, so the left side of the equation, I am going to put the value that is already given, which is 100. And on the right side, we are going to find the perimeter based on this diagram. Okay, so imagine we don't have the 100 here. How are we going to find the perimeter of the tiles area? Okay, which we need to identify the lines, right? So the lines to find the perimeter would be line OA, okay, the radius here, the arc AC, okay, which is the curved line here, arc AC, and the line OC. Okay, so once we add up these three values, it would be the perimeter. So now let us find the values of each of the lines here, but of course we need to involve the minor angle as well. Otherwise we cannot use this equation to find the minor angle. Okay, so means that inside here there must be theta, right? The theta here, the minor angle, right? So for OA, so OA here is the radius of the circle, which we already know is 30 meters. Okay, so OA here is 30. And for the arc AC, so how do we find the length of arc? So we need to look at our formula sheet. Okay, so based on our formula sheet, 27 and 28 would be from this chapter. Okay, so to find the arc length, it would be this formula, S equals to R theta, radius of the circle, multiply with its angle. Okay, so arc AC belongs to the minor sector here, so we can use the radius of this minor sector, which is 30. And we are going to multiply with the angle, which is the theta here, right? Okay, which is the angle that we are trying to find. So I'm just going to put theta here. Alright, and then for line OC, which is also the radius of the circle, so this is 30. Okay, so now you can see that the right side all has transformed to values and also the angle that we are trying to find. Okay, so let us rearrange this equation here and there and we find out the value of theta. Okay, so the two 30s here, this one and this one, I'm going to move it to the left side minus with 100, so it will be 40 here. And I'm going to move this 30 to the other side to divide with 40. So our angle would be 4 over 3 radians. And for part B, we need to figure out the area of the flowers area, which means it is the area of the shaded region. Okay, so to find out area of shaded region, I'll always recommend students to use these two methods. Alright, so the first method is big shape minus out the small shape, and the second method is to add up all the shapes. So for the first method, let me use this question as an example. Alright, so big shape would be the shapes that includes the shaded region. Okay, a recognizable shape that includes the shaded region. So from this diagram, I can see that the shape that includes the shaded region would be this sector, OPR. Right? It's a recognizable shape and it includes the region that we want. Right? But of course, if we want to find the area, we cannot just simply take the entire thing, right? We need to remove some parts of the big shape. So this is where small shape comes in. It is the shape that I want to remove from the big shape. Okay, a recognizable shape that I want to remove from this big shape. Okay, so the parts that I need to remove is here, right? Which is also the minor sector, right? Which is also a recognizable shape. So if we want to find out the area of the shaded region, it will be this big shape minus out this small shape to find out the area. Okay, so to find out the area of the flowers area, it would be this sector OPR minus out the area of the sector OAC. Okay, so this is how we use the big shape minus small shape method. So how about the second method, add up all the shapes? Okay, so let me give you a simple example. So let's say we are trying to find the area of this entire region. Okay, so above here is actually a semicircle, below here is actually a rectangle. So for this kind of situations, we need to separate the region or split the region based on the shapes that we can recognize, right? Which is, I'm going to separate it here. So now you can clearly see that above is a semicircle and below here is a rectangle, right? So to find out the area of the shaded region, we recognize all the shapes that we have first, okay? And then we try to find the area of all the shapes that we have based on the formulas that we have learned. And then we add them up, both of them together, to find out the entire area. Okay, recognize the shapes. Recognize all the shapes, find out its area, and add up all of them together. Okay, so this is the second method, add up all the shapes. Alright, so now let's go back to our question here. So we are trying to find the area of sector OPR and OAC. So how do we do that? Well, we can look at our formula sheet. Formula 28, area of sector equals to 1 over 2 r squared theta. Okay, so for area sector OPR, let's start off with 1 over 2. But how about the radius? Okay, here we don't have the radius yet, but we do know the radius of this circle, right? Which is 9OA, which is 30 meters, and we do know its part, which is 3. So 3 parts equals to 30 meters. So why not we find the length for one part first? And now we see that for the radius of the sector OPR, which is this line OP, the parts is 3 plus 1, which is 4. Okay, so from 1 to 4 we multiply 4, right? So here we also multiply 4, so 10 multiplied by 4, it would be 40. Okay, so the radius of the sector OPR is 40. And don't forget to put a square here. And we are followed by the theta. So theta is the minor angle which we have already found in part A, which is 4/3. Okay, so take note, yeah, only these two formula uses radians. Okay, these two formula uses radians. The other formulas in the formula sheet that uses angles, all of them are degrees. Okay, so take note, yeah, for formula 27 and 28 uses radians, the other formulas uses degrees. Okay, so now coming back here, let's find out the area of sector OAC. Okay, so same thing, 1/2 multiply with the radius of the sector which we have already found, which is 30. Okay, we're gonna put a square here and multiply with the angle, which is 4/3. Okay, so once you put this into your calculator, you can find out the answer would be 1400/3 for the fractions version. And if you want to write it into decimals, it will be 466.67. So both of these answers are acceptable. For question 3, it is a unique question and it comes from the chapter progressions. So in part A, we are given these 3 consecutive terms on an arithmetic progression. So we are going to use arithmetic progression to solve this question. Alright, so consecutive here means back to back. Right, so those terms would be P, Q, and R. And we need to find out the relation between P, Q, and R. Okay, so this means from this arithmetic progression, we need to form an equation with P, Q, and R inside it. Okay, so we need to form an equation based on P, Q, and R. So how are we going to do that? Well, we need to first understand how does arithmetic progression work. Alright, so arithmetic progression is a sequence of numbers. Alright, and if we want to get the next number, usually we add or minus. Okay, so let's say I add 2 here, and then I'll get 4. And if we want to find the next number, we just add the same number also. So here will be 6, and so on. Okay, so for arithmetic progression, usually they use D to add to get the next number, right? So here it would be D. So D, of course, can be positive or negative. Alright, so coming back here, so how do we form the equation based on P, Q, and R? Okay, so let's draw a similar diagram, something like this. Okay, P, Q, and R here. So again, if we want to find the next value, we need to add D, right? P to add D, then we'll get Q. And if we want to find the next number, again, from Q, we add D to get R. So let's use this diagram to form equations. Okay, so meaning for the first part here, clearly it says that if we have P, we add D, then we will get Q, right? And for the second part of the diagram, let's form an equation also. So here will be Q plus D equals to R. Alright, so as you can see, both of these equations have D. So why not I remain D on the left side for both of these equations and everything move to the right side. Okay, so why I do this is because both of them have D. And what I can do is I can equate the values from the first equation and the second equation. Right? Because both of them have D, the same value. right? So now you can see in this equation, everything is P, Q, and R already. Right? So if we have found this one, here is just very simple. We just simplify the equation only. So for the Q, I'm going to move it to the left side here. So Q plus Q here will be 2Q. And for the negative P here, I'm going to move it to the right side. So here will be R plus P. Okay, so this would be the relationship of P, Q, and R. For part B, we are given the first three positive terms. Okay, so let's take note of the word positive here. Alright, and it says we are using a geometric progression. Okay, so we're going to use geometric progression for this question. Right, and the terms will be x minus 4, x, and 5x minus 12. So now we need to figure out the value of x. Okay, so let's understand how does geometric progression works. Okay, so it's similar to arithmetic progression, which has a sequence of numbers, but they will be multiplying or dividing a value to get the next number. Right, so for example, let's say my first value is 2. Then if I want to get the next value, so let's say I multiply 2, then I will get 4. Right? And then from 4, if I want to get the next number, also we are going to multiply the same value, which is 2, and then we can get the next number, which is 8, and so on. Right? So for geometric progression, usually they will be using R. Alright? So coming back here, how do we find the value of x based on these values? So actually we can use the same technique in part A just now. Let us draw a similar diagram, something like this, using these three values. Okay, x minus 4, x, and 5x minus 12. Right? So if we want to get the next number, so let's say we have x minus 4, to get x, we need to multiply r, right? From x to get 5x minus 12, we also multiply r. And then, again, we can use back the same technique in part A. We are going to form equations based on this diagram. Right? So for the first part of the diagram, right? First part of the diagram is x minus 4 multiply with r to get x, right? And the second part of the diagram is x multiply r to get 5x minus 12. Okay, and since both of the equations here have r, so I'm going to remain r on the left side, everything else move to the right side. Okay, so for these two values, x minus 4 and x, once we move, it will be divided. Okay, and since both of them have r, I can equate the values of these two equations to form an equation. Okay, which is something like this. Same exact technique in part A. Right, so now you can see that in this equation, everything is in x, and we can use this equation to find the value of x. Alright, so to simplify this equation, what we can do is we can cross multiply it, right? Something like this. So the denominator on the right side multiply with this value, denominator on the left side multiply with this value. Okay, so on the left side it will be x times x, which is x squared, and on the right side it would be these two values multiplied together. So what we are going to do here is to just cross multiply lah. So 5x multiply with x, 5x multiply with negative 4, and negative 12 multiply with x, negative 12 multiply with negative 4. Okay, so we are going to simplify this part of the equation, negative 20x, negative 12. So add them up together, it will be 32. And for the x squared here, I'm going to move it to the right side. So 5 minus 1x squared, it would be 4x squared. Okay, and then if you see for these three numbers, all of them can be divided by 4. Okay, so let us simplify by dividing by 4, and then we move them to the left side. Alright, and then you can see that this is actually a quadratic equation. Okay, so we can use factorization by using the calculator to find out the two values of x. Okay, so this time it's x equals to 2 or x equals to 6. But let us not make the same mistake in question 1. Let us go back to the previous question and see that whether our x values or our x answers are valid or not. So for this one, again, we need to see whether our answers are valid or not based on the question. Okay, because in this question, just now we have seen that it says the first 3 positive, alright, positive terms. So to see whether these two x values are valid or not, we need to substitute it back here to see whether the terms are positive or not. Okay, so let's do it one by one. So if x equals to 2, I substitute into these 3 numbers. You can see that for the first value, it is already negative, right? 2 minus 4, which is negative 2. And for the third value as well, 5 multiplied with 2, minus with 12, it's also a negative value. So our x equals to 2 value must be rejected. Okay, so how about x equals to 6? Okay, so let us see when we substitute. Okay, it's great because all of the values here are all positive. Okay, so x equals to 6 would be our answer, and x equals to 2 we need to reject. Okay, so please make sure to double check the answers first to see whether the answers are valid or not. Next question, going into vectors, and in part A, we need to decide whether this quantity is a scalar quantity or a vector quantity. Okay, and then we need to give our reason why. So for the sentence here, let us see what it is. So it says water has a density of around 1000 kg per meter cube. Okay, so to decide whether it's a scalar or a vector quantity, we need to see the differences first. Okay, so a scalar quantity means this quantity has magnitude only. For a vector, it also has the magnitude, but this is the main difference. A vector quantity has the direction. Okay, so what does it mean? Right, so magnitude, if you don't understand, it's actually just a value. Alright, so let me give you a very simple example. What is scalar and what is vector? Okay, so let's say the distance from point A to B is 1 km. So this is actually a scalar quantity because it only has the value or the magnitude. For vector, it would be the distance from point A to B is also 1 km, but we are traveling to the north. So you can see that there is the direction given. So this is actually a vector quantity. It has the magnitude, which is 1 km, and also the direction, which is going north. So coming back to this sentence here, it says that the water has a density of 1000 kg per m cube or meters cube. So this value is actually the magnitude, right? The value. But are we given the direction? No, right? So it's very clear that this is actually a scalar quantity. So we can write it in this way. So this is actually a scalar quantity. Okay, let me change this to because. Okay, because the quantity has magnitude but does not have the direction. For the next part, in this sentence alone, there's a few information given. So let me explain these one by one through this diagram here. Okay, so the first vector given here is vector OA, which is here, and the value is 5p. And for the second vector given is OB, which is here, and the value is 10q. So I will recommend y'all to do this also, which is to highlight the lines that already have the vectors, is because we can identify them easily and use them to find the other vectors easily, right? Because those lines already have the vectors. Okay? And also for the next part is we are given the ratio between AD and DB, which is the ratio of this line, ADB. Okay, so AD here is 2 parts and DB here is 3 parts. Okay, for the next two equations here, it is describing the relationship between the vectors. Okay, so AC and OB is related through M. Okay, so let me label these two vectors in blue to indicate that these two vectors are related by M. Okay, and then the second equation here, these two vectors are related by N. Okay, so let me label those two vectors by orange. Sorry, using orange. Okay, so it would be here and here. Okay, so this star is OD and this star is for OC. Alright, so for the first part, we need to find out the vector OC in terms of M. Okay, so what does this mean? Okay, so this means that when we are finding the vector OC, we need to use the vector AC or OB. Okay, either one. So in our answer, there would be M. Okay, because again, these two vectors are related by M. Alright, so how do we find the vector? First thing first, we need to set our route, our direction. So meaning, if we are at point A, how do we go to point C? And we need to use these either one of these two vectors. Okay, so from here, I think we can go from O to A, right? Why I choose O to A is because this line is highlighted, which means there is the vector already. Okay, so easier for us to find the other vector, right? So O to A, and then I can go from A to C, right? Because I need to have a vector that is related by M, that uses M. Alright, so this will be our route. OC to go from O to A, and then A to C. Okay, so OA we have the value already, which is 5p, so I'm gonna put it here. And how about AC? Okay, so if we look at this equation, AC equals to MOB, so why not we use this, right? So here it would be MOB. Alright, but here there's an error, right? Reason is because for vectors in the same line, it cannot have two forms of vector. So what are the two forms? So basically is the vector P here and OB. These two are different forms of vector and they cannot appear on the same line. So meaning the same line must have one form of vector only. Either it's all of this or all of this. Okay, so here how do we fix our error is, instead of just changing to 5p, why not we change it to OA first? Okay, so now I can see that these two vectors, both of them have the same form, right? Which is this one. Okay, not this one. Right, so make sure for each of the lines, when you are calculating the vectors, make sure it has the same form. So if you want to change the form, all of the vectors change to that format. Alright, so coming back here, for the OA, I'm going to remake it as OA first, and the AC, I'm going to change to MOB. Alright, so OA we have the vector already, which is 5p, but how about OB? Okay, so OB I think we already have because it's given here, 10q. Okay, so means here for both of the vectors here, I am going to change their forms together. Right, so OA will become 5p and OB will become 10q. Right, you can see again, this line has only have one form of vector, which is this one, okay, which has a curly line at the back, sorry, at the bottom. Alright, so we simplify a bit and this would be our vector, which has m. For part 2, we need to express OC, which is actually the same vector in part 1, it's just that now we need to express in terms of n. Okay, so just now in part 1, we are finding OC, we used either one of these two vectors, right? But if you see part 2, when we are finding OC again, you can see that the equation here, there is OC also. Right? The vector we are trying to find is actually one of the related vectors of n. Okay, so it is the same. How are we going to solve this? Right, so this one will be a bit special. Instead of finding the root, right, we can just use the equation here. Okay, so basically means for the n, I'm going to move it to the other side. So here would be OC equals to 1 over n OD. So for this question, why did I say that we cannot find the root of OC? Okay, so let's imagine that we are finding the root OC and we need to use these two vectors. Okay, so the fastest way to go from O to C is through here, right? O to D and then D to C. Okay, so let's find out the vectors one by one. Alright, so O to D. So for O to D, of course, we can find the vector through O to B and then B to D, right? Okay, so let's say if there's the vector here for the gray color part here. Okay, we can find it. But the issue is D to C. Okay, so if we imagine we are trying to find the vector from D to C, okay, which we need to pass through D to A and then A to C. So again, DA we can find the vector. It's no issue. But we don't know the vector of AC. And this vector AC uses M. But in our question, we need to use N. It cannot have M inside. Okay, so that's why we cannot find the root. Okay, reason is because we used AC. AC is related through M. And in the question here, we cannot have M. So we cannot find the root. Alright, so we are going to use this way, which is using the equation, rearrange here and there to find the vector. Okay, so now if we want to find OC, we first need to figure out OD. Okay, so let me rub off some of the irrelevant things here. So to find out the vector OD, so let us set our root. Okay, so from O, which we are here, how do we go to D? Right, so the fastest way I would say is from O to A using the highlighted line. And this one I think no choice, we have to go through the gray line. So from A to D. Okay, so OD would be OA plus AD. Okay, so now OA we already have the vector, but let us not change it to 5p first. Let's remain it. So for AD, we know that it is actually 2 parts of the entire line here, which is 5 parts. Okay, so usually when we are finding the vector for part of the line, usually it will be easier for us to find the vector of the entire line. Okay, so instead of finding AD, why not we find out AB first? Okay, but of course, AD is not the entire line of AB, right? So we need to multiply something here. Okay, which is the ratio lah. So AD is just 2 parts, so I'm going to put 2 on top. And we need to look at the parts of the entire line, which is 2 plus 3. So here would be 5. Okay, so now we change AD to AB and we multiply this fraction here. Because AD is 2 parts, the entire line is 5 parts. Okay, so here AD, it would be 2 over 5 AB. Okay, so now we can go another step. So OA, we have the vector already, but we don't change it yet because we don't know AB yet. Okay, so now let's focus on finding AB. Okay, and let me use the green color pen. Okay, green color pen. So from A to B, what is the fastest way to go from A to B? Okay, I think we can use the highlighted lines. It will be easier for us to find the vectors. So A to O, and then O straight to B. Okay, simple as that. So A to O and O to B. So A to O and O to B, we already have the vectors. So now for each of the vectors here, I can change their forms together. Okay, so OA here will be 5P. Right, and this one, AO. Okay, AO is going to the right side. But the vector given here is going to the left. Okay, so since it is the opposite direction, which means we need to add negative, okay, to this vector. So we cannot put 5P. Here we need to put negative 5P because it is the opposite direction. Okay, for OB, straightforward because we are going through the same direction, so it's 10Q. Okay, so now we can multiply this fraction into the bracket here and then simplify here a bit, and we can find the vector in terms of n. So in part 3, hence we need to find the value of m and n. Okay, so means in part 1 and part 2, we are finding the same vector. It's just that it is in terms of m for part 1 and in terms of n for part 2. Which means the values of the same vector is the same. Okay, so means for 5 and 3 over n, both of them are actually the same. Alright, and for the values of vector q, which is 10m, and 4 over n, both of them are the same also, because both of them are from the same vector. Okay, so to find the value of m and n, we can equate these values together. Right, so for vector p, it will be 5 equal to 3 over n, and q vector would be 10m with 4n. Sorry, 4 over n. Alright, so to find the values, let me rearrange this one first because we can straight find the value of n already, which is 3 over 5. And then for this value of n, I can substitute inside here first. Right, to find the value of m. Okay, so 4 over 3 over 5 and 10 move to the other side, then you will get m is equals to 2 over 3. Right, and with that, we have found out our value of m and n. For the fifth question focuses on quadratic functions, and in part A, we need to solve this quadratic equation. So meaning we need to figure out the value of x. But if you see I put the unique label here, is because we need to write the answer in the form of a plus bi. Alright, so I think a lot of students don't really know what I is because we don't really focus a lot on I. And technically this I shouldn't be in this paper because I is not in the SPM syllabus. But it's okay. So since it already appeared in this question, so why not we take this opportunity to learn what is I. Okay, so I here actually has a name. So I is actually called the imaginary number. And this I also has its own value. Okay, so I here is also square root minus 1. right? So we know that the value of the square root cannot be negative, otherwise it will produce an error. But this one, we can also change it to I. Alright, so why we need to learn I is because for certain questions, right, when we are solving the equation, so let's say this one, we are trying to find the value of x, but later when you see, when we are doing the steps, you will see that there will be a square root. The inside of the square root is a negative value. Okay, so when we see something like this, we can change it to I. So we can continue to solve the question. So meaning this negative square root, it wouldn't be a blocker for us solving the question. We can continue to solve by changing the negative square root to become I. Alright, so coming back here, to solve the quadratic equation, so one of the ways is factorization, right? Factorization by using the calculator. So means to find the two values of x. So if you have this type of calculator, what we need to do is we can press mode and then we can go to 5. So EQN is called equation. Okay, and then we find the quadratic equation, right, which is this one, right? You can see that the power here, the x power here is 2. So we're gonna press 3. Okay, and then it asks you to fill in the values of a, b, and c. Okay, so the value of a here, we can go back to this equation. So a here is the value of x squared, which is 3. B would be the value of x, which is negative 5. And c would be the value which does not have x, which is 3. Okay, so once you press enter, okay, you can see that we have the two values of x already, right? But if you look closely to the answer, right, okay, so it has an I, which is correct, right? Because our answer will have an I, but there is this square root here. So imagine if we just write these two answers into our answer sheet here, the examiner will ask, how did you figure out this value of square root? How suddenly will appear square root 11? So this is an indicator where we cannot use the first method, which is the factorization way, to find out the value of x. Okay, reason is because we need to show how did we figure out the value of the square root here, which is 11. Okay, we need to show it out. So the other way that we can do it is through this formula, which is in the formula sheet, the quadratic formula. Alright, another way to find out the value of x. So what we need to do here is just to figure out the values of a, b, and c. Okay, so the value of a would be 3, which is the value of x squared. B would be negative 5, which is the value of x, and c would be 3, which is the value that does not have x. Okay, so let's follow the quadratic formula and to substitute the values inside. Alright, so here will be negative b, b is negative 5, and then the square root inside would be b squared, which is negative 5 squared, minus 4, and multiply with the a, which is 3, and c, which is 3 also. And then in the denominator, it will be 2 times a, which is 3. Okay, so once you simplify, it will be something like this. And if you notice, the value inside the square root is 11, right? Which is the value that we have found in our calculator just now. So this means we have proven how did we find out the value inside the square root through quadratic formula. Okay, by putting the b, a, and c inside the square root here to figure out the answer. Okay, so now based on our answer here, we still need to figure out how to have I inside it. Alright, so we know that I is square root negative 1. So here there is a square root here and there's a negative here. So means we need to do some things in this square root. Okay, so the way to do this is we can split the negative and the 11 inside the square root. So means negative 1 and 11. Okay, and then I am going to split this one square root into two square roots. So meaning one of the square roots would be negative 1 and the other square root would be 11. Okay, so it will be something like this. And since we have square root negative 1, so basically this value would become I. Right? So for next line, okay, so now I have divided 6 with these two values here, the 5 and the square root 11. So it will be something like this. Okay, and then the square root negative 1 here, I can just straight change to I. Okay, which satisfies the form that is required, A plus BI. So this is the A, this is the B, and at the back is the I. Okay, so since we have a plus minus here, means that we have two answers. So let's write out the two answers here. Okay, so it would be the positive version and the negative version here. But you may be asking this question, teacher, in the question here it says the answer must be in the form of A plus BI. There's the plus here. So if my answer have negative or minus, should I reject that answer? Right, so technically we don't need to, right? We can accept both x values as our answer. Okay, reason is because in this form, we don't know what is the value of b. Either it is positive or negative, right? So if in our answers we have both positive and negative, then we can accept both positive and negative as our answers, right? Again, because we don't know what is the value of b. Okay, so for the first answer is where b is positive, and for the second answer is where b is negative. Okay, so this part of the question here is just telling us that we need to have that structure of the answer. So meaning we have two values, one is a and one is b, but a here cannot have I, b here must have I. Okay, so in our answers here, you can see that one value does not have I, right? And the other value does have I. Okay, so we have already followed the form of the answer. One value does not have I, the other value has I. For part B, it says that we have this quadratic equation and it says it has two equal real roots, right? Two equal real roots, and we need to determine the ratio of HK. Right, so when you see roots, you need to think of the discriminant. So what is the discriminant? The discriminant is b squared negative 4ac. Okay, discriminant is this one, b squared negative 4ac. So as we know, we have three different types of answers: greater than 0, equal to 0, or less than 0. Okay, so if we see two equal real roots, which one should it be? Okay, I give you 5 seconds to think about this. And the answer is b squared negative 4ac equals to 0. Okay, because two equal real roots means it only has one value of x. Okay, and you can see in this graph only touches the x-axis at one point. Okay, so it would be b squared negative 4ac equals to 0. So now if you want to find out the ratio, we can use this, but first we need to figure out the values of b, a, and c first. Okay, so let's use this equation and let's rearrange the equation a bit. Right, so for the h, I'm going to multiply inside the bracket here. Right, so here will be hx squared plus h, and the k I'm going to remain it. For this one, I'm going to move this part to the left side, so here will be negative. Okay, and let me rearrange a bit. So for the values that have x squared, I'm going to put it at the front first, which is this one. And then I'm going to put the value that has x, which is this one. And at the back, I'm going to put the value that does not have x, which is plus h plus k. Okay, so why I arrange in this way is because I want to find out the values of a, b, and c. Okay, so again, value of a would be the value of x squared, which is h. B will be the value of x, which is this one. And c will be the values that does not have x. Alright, so let us substitute these three values inside the discriminant here. Alright, so once you substitute, it will be something like this, and let us simplify the equation again. So this one, if we square a negative, basically negative, negative, positive, right? So we can just ignore this one. So here we just need to square the things inside here. Okay, so once you square or you cross multiply, it will be something like this, right? So cross multiply meaning 2h minus k, 2h minus k. So 2h multiply with 2h, 2h multiply with negative k multiply with 2h, negative k multiply with negative k to get this result. Alright, and then for here, I'm going to multiply negative 4h into these two values. So it would be something like this. Alright, and then let us simplify even further. So this one, 4h squared and negative 4h squared, we can cancel off each other. Because you minus them, it will be 0. And these two values are actually the same, so we can add them up together. So here will be negative 8hk, and the k square here, we can just remain it. Alright, so what I'm going to do now is I'm going to remain h on the left side, everything else to the right side. Okay, so this k square, I'm going to move it first. Alright, and since both sides have k, so let me cross off a k for both sides. So meaning cross off one k here and cross off a k here. Right, and the negative I can also cross off. So here would be something like this. Alright, so how do we find the ratio hk based on here? So what I will do is I will move the k to the left side. So meaning here will be h over k, and for the value here, I'm going to move it to the right side. So why I did this is because you can clearly see by comparing above and below. So above, you can see that h is equals to 1, which means h has 1 part. And below, if we compare, means k has 8 parts. Okay, so this can actually be transformed into a ratio, right? H is 1 part, k is 8 parts. Okay, and we have found out the ratio of hk, which is 1 to 8. For the next question, focuses on functions. So here we have two functions. So h of x equals to 3x plus 1, and we have khx. So this is a composite function. Okay, so composite function would be functions have two or more functions together. Okay, so for example, this one, khx. So it will be this value. So we need to find in part A the value of m if the inverse of h of m minus 1 equals to 3. Okay, so the value that we are trying to find is inside here. Alright, so to find value of m, why not we draw some diagrams by focusing on the function h first. Okay, let's draw diagrams for these two functions. So for this one, means that if we have x, and if we put into h, it will have this result, 3x plus 1. For this one, if m minus 1 is put into inverse of h, then it would be 3. Or meaning, if I want to go from 3 to m minus 1, I need to put into the inverse of h, which is h itself, right? The original h itself, and then I put inside it, then I can get the original value m minus 1, right? Because inverse of h is the opposite of h, right? So since we have the function h already, so from this diagram, why not we just focus on the h function? Okay, so meaning 3, right, this one, I put into h, then I can get m minus 1. Alright, so now we can see we have two different kinds of diagrams, but they are using the same function. So since it has the same function, why not we compare the values here? So meaning x here is equals to 3, 3x plus 1 is equals to m minus 1. Okay, so we can use this way to find out the value of m. Okay, so for part A, we are going to equate these two values together. So this would be x equals to 3, and this one, we can equate them together first, and then we substitute the value of x inside here. Alright, so here will become 3, and 3 times 3 will be 9, plus 1 will be 10, and then this negative 1 move to the other side, you'll be adding 1 again, so m would be 11. For part B, we need to find out the value of k of x plus 1. But the issue is we don't really know the function k yet. Okay, so let us find the function k first before we find the value. Alright, and how do we find the function k? Well, we can look at the composite function here because it has the function k here. Okay, so let's write out the composite function first. Okay, and what we can do is let us substitute the h of x here because we already have the value of the function, which is 3x plus 1. Okay, so basically for the h of x here will be changed to 3x plus 1. So for the next few steps to find out the function k, I would like to share you all this technique, so I hope it helps you all to understand and also to memorize the steps even better. Okay, it's through a thing that we do all the time, which is washing clothes. Alright, so let us assume that we have a shirt here and inside of it is dirty. Okay, inside of it is dirty. It's similar to our function now. We have a function on the outside, but inside of it, we have a value, the 3x plus 1. So our aim here, of course, for the shirt is to clean the shirt at the inside. And for our equation here is to simplify this, the thing inside the function. Okay, so how do we do that? So of course, we need to have our materials ready, right? So to clean the shirt, of course, we need to have a soap, right? But how about our equation here? So this one will be a bit funny because the soap here is actually the thing inside the function, 3x plus 1. Okay, and I'm going to let it as a unknown, an unknown. So here will be y equals to the thing inside the function, right? So here will be y equals to 3x plus 1, and this would be our soap. So once we have our materials ready, then we can go through the 3-step method to clean the shirt. Okay, so the first step to clean the shirt, of course, is to flip the shirt inside out because we want to access the things on the inside of the shirt, right? So here, what are we flipping? So from this equation, we are going to flip the left side of the equation from y to x. So basically, x must remain on the left side, everything else move to the right side. Okay, so we are going to flip the left side of the equation from y to x. Right, so this will be our first step. So the second step is to apply the soap. Okay, so meaning for this soap, we are going to clean the inside of the shirt already. Okay, so how about here? So we are going to use the two equations that we have formed just now, and we are going to apply it into this equation. Okay, so this means for the 3x plus 1 here, because we let it as y just now, so left side it would be k of y. Alright, and then for the right side of the equation, we have the x here, right? We have the x here, and we have an equation here, x equals to y minus 1 over 3. So we can substitute the value of x here with this value. Okay, so basically all the x will change to this value already. So here will be y minus 1 over 3 square, and followed by the x at the back. And the 5 we can remain it. Okay, so for this part, let us simplify the equation first. Okay, especially for this one, because we need to square. Alright, so once you square the things inside here, it would be this one. Right? So y minus 1 basically is just y minus 1 multiply with itself lah, and then we just cross multiply. Okay, and then you will get this result, and the 3 here is just to square, so it becomes 9. And for this one, it's just 6 divided by 3. Okay, 6 divided by 3, so it becomes 2 here. Right, and then we simplify even further. So basically this 9 we can cross off, because 9 divided by 9, and the things on the top will not be affected, and the 2 here I multiply into the bracket here, so it will be 2y minus 2 here. Okay, and then I simplify this even further, so it will be just y squared plus 4. Okay, because this one and this one, they have the different signs, so of course they will be crossed off. Okay, it will become 0, and plus 1 minus 2 plus 5, it will be 4. Okay, so now we have simplified already, and let's go to the third step. Right, so the third step, once we clean the inside of the shirt already, of course we need to flip it back. Right, flip the shirt back inside out. So what we are going to do here is, so just now from y we flip to x. So here we do the same thing also. From y we flip to x. Okay, so with the 3-step method, we have found out our k function already, and we have cleaned the shirt. Okay, so now we have the k function, so let us see what do we need to find. Okay, so we need to find where k is k of x plus 1. So meaning the value inside the function, we need to change from x to become x plus 1. Okay, so this means for all the values of x here, we need to change it to x plus 1. Okay, so means that this x on the right side, we need to change it to x plus 1 also. Alright, so we need to square the value inside here, so it will become this value. So again, this is just to cross multiply lah, right, which is something like this. And then we simplify this, then we can get the answer. So it will be x squared plus 2x plus 5. For the next question, going into integration, so here we have a quadratic function, and in part A, we need to figure out the value of the integral of f of x from p to p. Okay, so let's focus on this. From p to p, what is the value? Okay, so here if you see there's only 1 mark, so means the working will be very short, or it will be something that we have learned before. Okay, so let's recall back the things that we have done in integration. Okay, so let us assume that we are finding areas. Okay, so let's say we have this curve, and then this is the x-axis. So let's say we are finding areas. Let's say this is 2, and let's say this is 3. Okay, so we can use integration to find out the area, right? So if I integrate from 2 to 3, of course I can find out a value. But what if, okay, what if the two values here are the same? So let's say it's 2. So we need to ask ourselves, can we find out an area if both of the values are the same? So it's actually just a line. If it's a line, means there is no area, right? So the answer would be 0. Okay, so this is a thing that we need to remember. Alright, so if the lower limit and the upper limit is the same, okay, lower limit and the upper limit is the same, then it will have no area. No area meaning the area is 0. For part B, we need to find out the value of m. So value of m is on the right side of this equation. Okay, and this 2m minus 1 is actually the value once we integrate f of x from 1 to 2. Right, so I think we need to figure out the value of this integral first, and then we equate with this one to see what is the value of m. Okay, so let's find out the value for this integral first. So let us substitute the function inside the integral. So before we integrate, usually I would recommend students to do is to split this value into parts by looking at the plus and the minus. Okay, so here it would be here. So you can clearly see that we are integrating two things. Alright, so we cannot split the negative here, alright, because the negative here is inside the bracket, and this negative is attached to 2, which is also attached to the bracket here. So we cannot split the things here, okay, because it's all multiplied. Alright, so once we have split, then we can start to integrate. Alright, so to integrate, again, we are going to add 1 to the power, and we are going to divide with the new power, which is 2 plus 1, which is 3. Okay, so it will be something like this. And for this value, since it does not have x, so I'm going to put x to it. So here will be negative 3x. Alright, so once we integrate already, make sure you don't forget to put the limits here, right? Which is 1 and 2 on the right side of the bracket. And the next thing that we're going to do is to substitute the two values into x and then to find out its difference. Okay, so this would be the result when we substitute x with 2. Alright, and we're going to minus with the result when we substitute 1 into x. Okay, so everything has changed to 1, and then we can simplify these by putting into the calculator. Alright, and your final answer would be negative 23 over 3. Okay, but please do not stop here because we still need to find out the value of m. Okay, we are not finding out the value of the integral only. Alright, so we're gonna equate this value with the 2m minus 1 here. So I'm going to move the negative 1 to the other side and the 2 to the other side also. So means divide with 2. Then you can get your m value is negative 10 over 3. So before we go to the next question, I would like to let you all know something about integration. Okay, so there is another special case of values during integration, okay, which is this one. So meaning there is a value for x and it's inside the bracket. So how do we integrate this, and is there any difference? So yes, there is. Okay, so let's do the same thing. So power, I'm going to add 1. So here would be negative 2, 2x minus 3, and this would be 3. And then we divide with the new value, right, which is 3. Hey, but the difference of this one is we need to divide the value of x. Okay, so means for the value of x is 2, right? So we are going to put the 2 at the denominator. right? Meaning we are going to divide with 2. Okay, so please take note, yeah, if there is a value of x inside the bracket, the value must be divided. For question 8, we are going into permutations and combinations, and in part A, we need to figure out the number of ways to arrange. Alright, arrange the words paru and para if there's no repetition. And it also asks us to find out the number of ways whether they are the same or not, and we need to explain it. Alright, so before we find the number of ways, let us ask ourselves this main question, which is this question a permutation question or a combination question? Okay, so I give you all a 5 seconds to think about this. So this is a permutation question. Okay, why? Because of the keyword here, arrange. Okay, because permutation involves arrangement, so we are going to use permutation to solve this question. Okay, so let's find out the number of ways to arrange the 2 words here. Alright, so let's pull down the list of formulas for permutation. Okay, so let's focus on the first word, P-A-R-U. So we're going to arrange all of the letters here. So we are going to look at the first row. Alright, but here it doesn't say we need to arrange in a circular manner or in a circle. So we are going to use this formula, the n factorial. Okay, so since we have 4 letters here, then the answer would be 4 factorial. Straightforward, right? Which is 24. How about para, P-A-R-A? Okay, so here it also has the same number of letters. So here would be also 4 factorial. Okay, but this one is a bit special because if you look closely to the letters here, we have identical letters. Alright, if there are identical letters, then we need to look at the last row. Okay, so it's the total ways and divide with the number of factorials here. Alright, so total ways we already have it, which is 4 factorial. But how about the denominator here? Okay, how many factorials do we need to divide here? Okay, so this one, the number of factorials here would be depending on the number of types of identical letters. So meaning how many type of letters that have identical? 1, right? Because it's just the letter A. So below here, we are just going to divide 1 factorial only, because we only have 1 type of letter which has identicals. But what is the value of the factorial? So this one, we can just look at how many letters of A do we have, which is 2, right? So here we are going to divide with 2 factorial. Okay, so this is how we use the identical way. Alright, so let me write off this. Okay, so 4 factorial divided by 2 factorial, so the total number of ways to arrange is 12. Okay, so we can answer the next part of the question, are the number of ways the same? So obviously it's not. Okay, why? Because there are repeated letters of A in P-A-R-A. For part B, it says that they need to form a team of 5 members to be selected to do an exhibition, and they need to select it from a group of 4 swimmers and 3 mountain climbers. Right? So we need to find out the number of ways that the team can be formed according to these 2 conditions. Okay, so again, the question that we need to ask ourselves before we solve the question, which is this question a permutation question or a combination question? Okay, so let me give you 5 seconds to think about the answer. And the answer is, this is a combination question. Okay, reason is because we are just forming the teams. We are not selecting the people and then we arrange them in the team. We are not doing that. We are just selecting the people to form the team, okay, which does not involve arrangement. Okay, so we are going to use the combination way, and for the first part here it says there is no condition. Okay, so meaning from the 7 people here, I will be choosing 5 of them to form the team. So this would be 7C5. From 7 people, I choose 5 of them. Okay, so once you put into calculator, you'll get the answer is 21. And for part 2, the condition is the swimmers must be more than the mountain climbers. Alright, so I would say this one has a lot of possibilities. So let us use a technique in combination, which is to draw out the table. Alright, which is something like this. Okay, so how to use this table is, for each of the columns here, I am going to represent it based on the groups that we have. Right, so we have 2 types of groups. One is the swimmers and one is the climber. Okay, so this would be the 2 groups that we have. And then let's on the left top side here, let us write out the total number of swimmers and total number of climbers that we have. Okay, so it's 4 and 3 respectively. And on the left side of the table, let us write out the number of members that we need, which is 5, right? So once we have our table ready, so we can list out all the possibilities based on the condition. So again, which is swimmers must be more than the mountain climbers. So to start off, let us start off with the most extreme case. Let us assume that all of the members here are the swimmers. So let's say we have 5 swimmers. But is this possible? The answer is no, right? Because we only have 4 swimmers. So we need to reject this possibility. So for the next possibility, let us minus 1 from the swimmer. Okay, so now we have 4 swimmers. Okay, so this one is possible because we have 4 swimmers. Alright, which means we have 1 climber here. So this can be our first possibility. Alright, for the next possibility, we can reduce the number of swimmers. So from 4, we can go to 3. So means that the number of climbers here will be 5 minus 3, which is 2. Right? So this can be our second possibility. So let's further reduce the swimmers. Okay, so let's say we go to 2. So means that the number of climbers would be 3, right? So this can be our third possibility, but are the number of swimmers more than the climbers? Right? Based on the condition here, the answer is no. Right? So this one cannot be our possibility also. Alright, so in total we have 2 possibilities only. Okay, so based on these 2 possibilities, let's figure out the number of ways. Right, so for the first possibility, it would be from 4 swimmers, I choose 4 of them. So here will be 4C4. And from 3 climbers, I'm going to choose 1 of them. So multiply with 3C1. Okay, this is the first possibility. And for the second possibility here, so I'm going to add. So I'm going to add 4, choose 3 of the swimmers. So it's 4C3. And then multiply with 3 climbers, I choose 2 of them. So it's multiply with 3C2. Okay, so once you put this into your calculator, then you can get the answer, which is 15. For the next question, focuses on linear law. So here we are given a diagram and it shows this curve. Alright, and if you see the axes, they are the small x and the small y. Okay, so what does this mean? Okay, so this means if we use the small x as the x-axis and the small y as the y-axis, it will produce a non-linear graph, because as you can see, this graph is a curve. Okay, but if you look at this sentence right, the variables x and y, they can be connected by this linear equation, y squared equals to mx plus n. Okay, so m and n here are the unknowns. Alright, so we know that for every linear equation, it will follow this, right? Y equals to mx plus c. So big Y here is the y-axis of the graph, m is the gradient, big X here is the x-axis of the graph, and c is the y-intercept. Okay, and then we can compare this equation and this equation. So if we look at the x-axis, okay, here it's still the small x. Okay, so this doesn't change. But if we look at the y-axis, the new y-axis of the graph, it has changed to become y squared. Alright, so this means if we change y to y squared, it will form a linear equation. Okay, so this means if the new x-axis is still x, but the new y-axis has changed to y squared, this graph can transform into a straight line, right? From a curve to a straight line. Okay, so this is what it means. Okay, so for part A, we need to figure out the value of m and n, which is inside this linear equation. Okay, so if we want to figure out two unknowns, we need to have two equations. So how do we find those equations? Alright, so let's go to the non-linear graph here. As you can see, we are given the coordinates of 2 points on this line. Okay, this means these coordinates are actually the small x and the small y. Okay, because their axis is small x and small y. Okay, so since these values are the values of x and y, so why not we substitute these values inside this equation and to find out the value of m and n. Okay, and then to form our two equations. Right, so let me use the first point example. So the x here will be changed to 5 and the y here will be changed to 2. Okay, so take note, yeah, this value of 2 is just y. Okay, so when we substitute inside, we only change the y value, not the entire thing. Okay, just the y value. So you can see here it's 2 to the power of 2. So same goes to the second point also. So x will be changed to 11 and the y here will be changed to 4. But again, remain the square. Do not straight remove it. Okay, so now let us simplify the things on the left side for both equations. Alright, and for the first equation, let me rearrange a bit to let n on the left side, everything else to the right side. Okay, why I do this is because I can substitute n with this value in the second equation. Okay, so this n will become 4 minus 5m. And now I can simplify this equation to find the value of m already. Alright, so here 11m minus 5m, so it will be 6m. And the 4, I will move it to the other side, so here will be 12. And then the 6, I move it to the other side, so means dividing 12. So m would be 2. So once we have the value of m, then I can substitute it back to this equation and to find the value of n, which is negative 6. Okay, so let us write the summary of our answers here. So m equals to 2 and n equals to negative 6. Okay, so once we substitute these values back into this linear equation, it will be something like this, right? So this means if we compare with the y equals to mx plus c, so our gradient would be 2 and our y-intercept would be negative 6. For part B, we need to sketch a linear graph of y squared against x, which basically is the graph that we have drawn just now, okay, which is this one. Alright, so to draw out the graph, make sure we label the axis correctly. Okay, so for the new x-axis, we need to rename it as small x. But for the new y-axis, we need to change it to y square. Right? Do not write the old label, which is y. We need to change it to y square because we are drawing the linear graph. Okay? So once we have labeled the axis correctly, then we can draw out this straight line. But how do we draw out this straight line? Okay, so first thing first, we need to have 2 points on this straight line. And how do we find the 2 points? So I will always recommend students this way, which is the fastest way, which is to find out the x-intercept and the y-intercept of this line. Okay, so let me change the labels here a bit. So it shouldn't be small y, it should be big Y. Okay, because we are drawing the linear graph, right? And the linear graph uses big X and big Y. So to reduce any confusion, I'm going to change them to be the big Y and the big X here. But the thing they're trying to find is still the same. Okay, we are still trying to find the y-intercept and the x-intercept. Okay, so for the y-intercept, just now we have found out already, which is the value of c, which is -6. Okay, so this is one of the points. And if we want to find out the x-intercept, we need to let y equals to 0. Okay, so this one I also need to change. This should be big Y. Okay, big Y equals to 0. Right, so this means this entire y square, we need to change it to 0 because this is the big Y. Okay, so the entire thing, including the square, we need to change it to 0. Okay, so it will be something like this. It is not this. Okay, again, because y square is y. Okay, the y square is y. So the entire thing, I need to change it to 0. Okay, so now if we rearrange the equation here and there, we can find out the x-intercept, which is 3. So this is the coordinate. Alright, so once we have the x-intercept and the y-intercept, we can plot it onto this graph. Okay, and then we can join these 2 points by drawing out the straight line. Okay, but that's not all. Okay, because just now in the original equation, the original graph, we are given these 2 points. So we need to see when we adjust to the linear graph here, where would be these 2 points at? Okay, so what we need to do here is very simple. We are just going to adjust the coordinates from xy to become xy square. Okay, so meaning the x coordinates will not change, but for the y values, we need to square them. Okay, so the 2 here, because we are changing to y square, so here will be 4. And for this y coordinate here, which is 4, I need to square it, so it will become 16. Okay, so now we have found out the coordinates once we adjust to the linear graph. Okay, and then let's plot these 2 points onto the linear graph here. Okay, so I'm going to put the x coordinate and the y coordinate of the 2 points, and I'm going to label them. Okay, and then to plot the points. Okay, so to draw the linear graph, again, we need to have the things which are on the original graph. We need to make sure when we are drawing the new graph, it is also included inside. Okay, which is the 2 points here. Okay, so once we transform, it will appear at these 2 points. For the 10th question, focuses on probability distributions. Okay, so here we have a person did a survey on the percentage of pupils that uses school buses to school. Alright, and this person found out that 42% of the pupils uses school buses to school. Alright, so with a sample of 3 pupils randomly selected, And I'm not really sure why for the next part it's not in the English version but only appears in the Malay version, which this sentence is very important. Alright, so it says that the value of X here represents the number of students who uses school buses. Okay, X is the number of students that uses school buses. So in part A it says that this value of X is binomial distributed or represented as distinct. Okay, so what is this? So this is actually, okay, X here is the random variable X, which is this one. Okay, this curvy line is called follow. Alright, so X follow B. What is B? B is binomial distribution. Alright, so X follow binomial distribution with the parameters of 3 and P here. Okay, so this 3 is actually the number of trials. So meaning how many times have the experiment repeated. Okay, and P here is the probability of success. Alright, and now we need to figure out the value of P here. So what is the probability of success? Okay, before we find P, let us recall back binomial distribution. So what is binomial distribution? Okay, so binomial distribution is the way we calculate the probability on experiments that has two outcomes. And these two outcomes are actually opposite of each other. So let me give you an example. Right, so let's say heads or tails. Right, these two outcomes are completely different from each other. Or up or down. Male or females. For our case here, in this question, it would be use school buses or do not use school buses. Okay, so for binomial distribution, the experiments will always have two outcomes. And for every binomial distribution question, we need to set our perspective. We need to decide, are we choosing to use school buses or not use school buses to answer the question here. Okay, but actually in this question, they already gave us which one to choose already, which is this sentence. Okay, which is why I say it's very important. Alright, this X is the number of students that uses school buses to school. Alright, so to answer the question here, we need to choose use school buses to answer the question. Okay, so for the probability of success here, so success here means that the probability of students that uses school buses, which is also given in the question, which is this sentence. 42% of the pupils uses school buses. Okay, so for our P, it would be 0.42. So for part B and part C, we are going to answer the questions where the students use the school buses. Okay, so for part B, we need to complete a binomial probability distribution table where the pupils use the school buses. Alright, which is in this table. Okay, so here we have already found the probability where among 3 pupils, none of the pupils use the school bus, which is 0.2, and among 3 pupils, only 1 of the student uses a school bus, which is 0.42. So now we need to figure out the probability where 2 students use the school bus and 3 students use the school bus. Okay, so how do we find the probabilities here? It's through one of the formulas in the formula sheet. Okay, formula 23. Okay, so this formula helps us to find the probability for binomial distribution. Okay, so what is the value of n and the value of p here? Okay, so value of n is the number of trials, which we have already saw in part A. Okay, which is 3. Okay, so why is it 3? So we can look at here. Sample of 3 pupils are randomly selected. We repeated the experiment 3 times. Okay, so for example, let's say among the students there, I choose one of the students out, and this would be my first trial. Okay, so in the first trial, I will see, okay, this student uses school bus or do not use school bus. Okay, so once that is done, then I will select another pupil as my second trial. Okay, and then I ask the same question again. Do you use school bus or you do not use school bus? Okay, and then once the second student is done, then I select another student, another pupil. So that will be my third trial. So as you can see, I repeated the experiment 3 times. Okay, which is why the value of n here is 3. Okay, and then the p here, so p is the probability of success, which we have already found in part A also, which is 0.42. Okay, so once we have the value of n and p, then we can use the formula here, right? So n would be 3, and here we have c, and the r would be based on the value here. Okay, so here will be 2, and p is 0.42, and the power here is r, which is 2, and q. So q is the probability of failure. And if you want to find the probability of failure, very simple, it's just 1 minus the probability of success. Okay, 1 minus 0.42 would be the probability of failure. Okay, and at the power part, it will be 3 minus r, which is 2. Okay, and then we can find out the probability. So same goes for probability when x equals to 3. So for the green numbers here, we just change it to 3. Okay, everything else remains the same. And we can find out the probability, which is 0.0741. Okay, so now we can put these two values inside this table, but as you can see, there's only 2 decimal places. Okay, so for the probabilities, let me change it to 2 decimal places. Okay, so it will be 0.31 and 0.07. And for part C, we need to draw the graph of this distribution in this diagram 1, and it's based on the values in part B. Okay, so to draw out the graph, first thing first, we need to label the x-axis and the y-axis correctly. Okay, so the x-axis will be this one. Alright, so let me label it as r. Alright, and then for the y-axis, it would be the probabilities here. Okay, so the y-axis would be probability where x equals to r. Alright, so now for the labels of the x-axis. So here we have 4 values, 0, 1, 2, 3. So for each line here, the thick line here, I'm going to label the 4 values here. Okay, 0, 1, 2, and 3. Right, so why did I not start 0 here? Okay, reason is because later on we would be drawing the lines. And you can see if we draw this line here, it is like conflicting with the y-axis here. And then you cannot see what is the probability where it's x equals to 0. Okay, so for the 0, I will usually move it here by not touching the y-axis. Okay, and for the y-axis labels, so I'm going to start 0 here, and then let me experiment this here and there. So let's say the big box here, right, the big box would be from here to here, it's 0.1. Okay, so let me add 0.1 for each of the big box here. So 0.2, 0.3, 0.4. Okay, so let me double check whether the 4 values here, can it be plotted here? Would it be the labels, it's too big or too small? Okay, so 0.42, it would be above 0.4 slightly. So it will be somewhere here. So I think we are good to go. Okay, these labels are okay. The scale of the labels are okay. Alright, so now let us plot the points onto this diagram. Right, so for the first one, where r equals to 0, the probability is 0.2. So it would be here. Okay, and when x equals to 1 or r equals to 1, the probability is 0.42, so it would be slightly higher than 0.4, so it would be somewhere here. Okay, so how do I know it's somewhere here? Okay, so just now, this entire big box is 0.1, right? And if we want to find the length of one small box, so it's 0.1 divide with 10 small boxes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so each small box will be 0.01. So if we want to find out 0.42, we just add 2 times of 0.01, right? So 0.4 plus these two values, it would be 0.42. And we can use the same technique for the other 2 points. Okay, so the last step is to draw the vertical lines from the plotted points to the x-axis here. Okay, so it will be something like this. From the plotted points, go down to the x-axis. Okay, and with that, we have drawn our binomial probability distribution graph. For question 11, I'm not going to reveal it's from which chapter first, but I'll reveal it during part A later. Okay, so let us go through the question first. So here we have the curves equation, and in this diagram you can see that there are 3 regions A, B, and C, and it is actually under the curve. Alright, so in part A, we need to find out the area of region A. So how do we find the area under the curve? So we can use the integration way. Okay, so this question comes from the integration chapter. Alright, so to find out the area of under the curve, we can use the integration way. But using integration, there are actually 2 ways to do it. Alright, either we are using the x-axis way or the y-axis way. But which one to choose? Right, so this one we need to look at the shape of region A. We need to see whether which of the axis here bounds or controls the region A. Okay, so if we look at the shape here, alright, we can look at this line. Okay, the horizontal line here. Okay, you can see that this line bounds or controls the region A. And this part of the line is actually part of the x-axis, right? So this means we need to use the x-axis way to find out the area of region A. Alright, so let's start off with writing the integral at the front and dx at the back. So dx is because we are using the x-axis way. Okay, and then the integral here, we are going to put the lower limit and the upper limit, which is the a and the b here. Okay, so the lower limit, which is a, is actually the lowest x value of region A, which is 1. And b here would be the upper limit, which means the maximum value of x of region A, which is 3. Okay, and for the y here, it would be the equation of the curve, right, which is this one. So we are going to substitute this inside the integral, but let me rearrange this part a bit. Okay, so instead of x squared at the bottom, I'm going to move it to the top. So here will be 12x power of negative 2. So why I adjust slightly is because it will be easier for us to integrate, because I can able to know what is the true power of x, okay, which is negative 2. Alright, so once we have found out all the values here, then we can start to integrate already. Okay, so to integrate, we will add 1 to the power, and then we are going to divide with the new power, which is negative 2 plus 1, which is minus 1 or negative 1. Okay, so this would be the result, and make sure you put the lower and the upper limits at the right side of the bracket here. Okay, and then we are going to substitute these two values inside here and to find the difference. Okay, so this would be the working where x is substituted with 3 and we're going to minus with the result where x is substituted with 1. Alright, so once we put this into the calculator, then you can find out the answer, which is 8 units square. But before we go to the next question, I would like to share you this. Okay, so let's focus on the x-axis. Alright, so here, if we have areas which are above the x-axis, it will be a positive value. For areas which are below the x-axis, it will be a negative value. So we need to be extra careful with this kind of questions. Okay, so example, so this is the x-axis and region A is below the x-axis and region B is above the x-axis. Okay, so to solve this kind of questions, we need to do two things. So first thing first, we need to calculate their areas separately. So meaning for those areas which are below the x-axis, we are going to calculate them first. Okay, which is we are going to calculate area A first. Then only we look at or we calculate the area of region B. Okay, so we calculate them separately first. Okay, so this one would be a positive value and this one would be a negative value. So if you want to find the area of these two regions, how do we add them up together, right? Because one is positive, one is negative. It's like we are finding the difference between these two regions, right? Because again, one is positive and one is negative. So meaning we are minusing these two values, right? So the second thing that we need to do is we need to apply modulus to these negative value regions, okay, which is this one. So we need to apply modulus so it will become a positive value. Okay, so once this area A is a positive value, then I can add up with area B to find out the total area. Okay, so for this kind of situations, we need to do two things. First thing first, we need to calculate them separately, and then we apply modulus for the areas which are below the x-axis. Okay, so same goes for the y-axis also. We need to calculate them separately and then to apply the modulus for areas which is on the left side of the y-axis. Okay, so again, we need to calculate them separately and apply modulus for negative areas. For part B, we need to figure out the value of P, okay, which is here, such that the regions B and C have the same area. Okay, so region B and region C, both of them have the same area. We need to figure out the value of P. So to do that, why not we form an equation where area of region B is equals to area of region C. And to find the area for these two regions, we are also going to use the integration way. Okay, so which way? Actually, we can just use the x-axis way because these three regions are actually bounded by the x-axis. Okay, so we are going to use the x-axis way for region B and C. Alright, so let's look at this one. So first thing first, let's put the integral at the front and dx at the back. Okay, so dx is because we are using the x-axis way. Alright, and the lower limit and the upper limit would be the smallest x value and the highest x value for region B. Okay, so the smallest x value here would be 3 and the highest x value would be P. Okay, and for the thing inside the integral, we are going to use the curse equation, which just now we have adjusted already, which is 12x power of minus 2 or negative 2. Alright, so same goes for area of region C as well. Integral at the front, dx at the back, and we're going to find the lower and the upper limits of region C. Okay, so lower limit would be the smallest x value of region C, which is p, and the upper limit would be the highest x value of region C, which is 5. Okay, and inside the integral, we are going to use the same thing. So now we can integrate these two things, but we don't have to integrate again because we have already done it in part A. So we can use the result in part A and to put it here. Okay, so this will be the result when we integrate this, right? And at the right side of this bracket, we are going to put the lower and the upper limits. So same goes for area of region C as well. Okay, and then now I am going to substitute the two values inside the bracket for both sides, and then we're going to find the differences. Okay, so for region B, it would be the result when we substitute x with p first. Okay, and then minus with the result when we substitute x with 3. Right, for region C, it would be 5 first into x, and then minus with the result where we substitute p into x. Okay, so now let us rearrange this equation here and there a bit. Okay, so for the values that has p, I'm going to move them to the left side. For those which does not have p, move to the right side. Okay, so this one will move to the left side, this one will move to the right side. Okay, so it will be something like this. Alright, so let's further simplify the equation here. So for the negative 1 at the denominator here is a bit annoying. So let me move all of this negative to the top. Alright, so everything here move to the top. Alright, and on the left side here, you can see that these two things are actually the same, so we can just add them up together. So it will be negative 24p to the power of minus 1. And for things on the right side, we can just put it into the calculator. Right, so it will become negative 32 over 5. So now if you see left side and right side, both of them are negative values. So I can just cross off both of the negative for both sides. Alright, and then the 24, I can move it to the right side to divide with this value, so it will get 4 over 15. Okay, so now for the p power of minus 1, I can change it into a fraction, so it become 1 over p. And what I will do here, because we want to find the value of p, right? So what I will do is to flip above and below for both sides, left and right. And we can find out the value of p, which is 15 over 4. Okay, so why here is just p is because once we flip is p over 1, which is also p, right? So yes, we have found our p value, which is 15 over 4. And the last question in section A, coming from trigonometric functions. So in part A, it says that using trigonometric ratios for special angles. Alright, so this one, let me explain it later. Alright, and here it says without using a calculator. Alright, without using a calculator, we need to find the values of these two things. Alright, so without using a calculator, how are we going to find the values? Alright, so for this kind of questions, let me introduce you all this method, which is called the 360 degrees A method. Alright, so for this method, it will be split into two parts. So the first part is the 360 degrees, and the second part is the big A here. Okay, so let's focus on the first part, which is the 360 degrees here. So for this one, you can view the digits or the symbols here separately. Okay, which means by looking, instead of looking 360 degrees as a whole, you look it as 3, 6, 0 and degree. So meaning there are 4 things here, and each of the things here have their own criteria. So the aim for the first part is we need to ensure the trigo values here satisfy all 4 criteria from each of the things here. Okay, so now you'll be asking, what is 3, what is 6, what is 0, and what is degree here? Okay, so let's go through them one by one. So 3 here represents the 3 main trigo functions, which is sine, cos, and tan. So here we need to ensure that the functions, the trigo functions here must be sine, cos, and tan. Or tan. So if it's not, for example this one which is cotangent here, we need to change it to tan or sine or cos. For the second one, which is 6, okay, so this one is a bit tricky. So this one is a sort of P, alright? So if I turn this 6 down and then I flip it, it's actually a P, okay? So this 6 is actually P, and P here represents positive. So means that the value of the angle inside the bracket here, it must be positive. So means that later on this value, we need to change it to positive. Alright, so this is the second criteria. The third one, which is the 0 here. Okay, 0 here you can view it as a cycle, or meaning one turn. Alright, one turn. So one cycle means that for our angle here, it needs to be less than 360 degrees or 2 pi. If it's in radians lah. Okay, so if you see here, actually both of them are actually less than 360 degrees, and this one is less than 2 pi. So for this one, it's fine. Okay, so for the third criteria here, we need to ensure that the values here is less than 360 degrees or 2 pi. Okay, and the last one, this degree, okay, this one is straightforward. It must be in degrees. So for example, the second one, you can see that it is in radians. Okay, so later on we need to change it to the degree format. Alright, so once it has satisfied these 4 criteria, then we can only go to the second part. So the second part, which is the big A here, stands for acute. Okay, so means that once we satisfy all these 4 criteria, and then we need to transform the angle into acute angle. So we know that acute angle is between 0 to 90 degrees. Right? So we need to transform the angle that we have later, and we need to transform it to be within 0 to 90 degrees. Okay, so for the steps later on, I will show it. Alright? So let's go to the first value here. Let's see whether this value satisfies all 4 criteria, and let's go through them one by one. Okay, so the first one, which is 3 stands for the 3 main trigo functions, and if we see the trigo function here, it's cos, which means we have satisfied because this is one of the 3 main trigo functions. Okay, so we can go to the second one, which is 6, which is also P, which stands for positive. So if we see the angle inside here, okay, this is a negative value, so we need to change it to positive. But how do we do that? Right, so this one we need to recall back something that we have learned in this chapter. Alright, so for sine and tan, if we have negative angles, let's say it's negative 45 degrees, if we want to remove the negative inside the bracket here, we just need to pull it out. So means that it will be negative sine 45 degrees and negative tan 45 degrees. But for cos, it's the special one, right? But by using the same negative angle, the negative will magically disappear. Right? So this negative value, once we pull out, it will disappear. So this only works for cos. Alright, so coming back here, for this negative, since it's cos, then it will magically disappear. So here will be cos 225 degrees. Okay, so why is it so? Okay, later after we discuss this question, let me explain it. Okay? Alright, so the angle here is positive already, so we have satisfied the second criteria, right? Which is to ensure the angle must be positive. Okay, and then we can go to the third criteria, which is 0, which means must be one cycle or less than 360 degrees, which in our angle here is already less than 360 degrees. So we have satisfied the third criteria. And we can go to the last one. So the last criteria here is the angle must be in degrees, which we have already done also. Okay, the angle is in degrees. So we have satisfied all 4 criteria here. So now we can go to the second part of the method, which is A. Okay, which is acute. So as you can see in the angle that we have now, it's 225. So we need to transform it to become within 0 to 90 degrees to transform it into an acute angle. So how do we do that? Well, we need to use the ASTC graph, okay, which is this one, ASTC graph. So here we need to do 2 things. The first thing is we need to identify from our angle here which quadrant does it belong to, okay, based on the angle here. So 225, it would be at the third quadrant, right, the T section here. Okay, so based on the section that we are in, we need to adjust the 225 according to these conditions. Okay, so for section T, or the third quadrant, for our angle 225, we need to minus with 180 degrees. Okay, minus with 180 degrees. So here will become cos 45. Right, so you can see that this angle has been transformed into an acute angle. Right, so this is the first thing that we need to do. We need to select the correct quadrant and we need to adjust the values from there. Okay, there's another thing that we need to do is we need to check whether the value here is positive or negative in the third quadrant or section T. Okay, because section T here means for the tan function, it will be the only trigo function which is positive, meaning sine and cos, it is negative. So here we have the cos function, which means the value here is a negative value. Okay, so means we need to add a negative in front because cos 225 in this quadrant is negative. So we need to add a negative here. Okay, so this is how we use the ASTC graph. So now we have the cos 45 already. How do we change it to its value? Because here it says without using a calculator. Alright, so let me share you this method. Okay, so this method is actually in the textbook, page 199 for both English and the Malay version. So it's called the hand method. And it literally uses the hand. Okay, so this method works by this way. So it is assumed that this little finger here is the x-axis and the thumb here is the y-axis. Okay, and for each of the finger here, based on this axis, will have its own angle. So for example, this little finger is 0 degrees. And then followed by the index finger, which is 30 degrees, 45, 60, and 90 degrees for the thumb. Alright, and each of the finger here have 2 values. Alright, so the first type of value will be starting from the x-axis. So meaning for the little finger here will be 0, and then followed by 1, 2, 3, 4. Okay, so this is for the first type of value. The second type of value is starting from the y-axis. So the thumb here would be 0, followed by 1, 2, 3, 4. Okay, so what does these numbers mean? Okay, so for the green numbers here, it is from the x-axis and it is for the sine function. Okay, for the blue values, which starts from the y-axis, it is for the cos function. Alright, so now let's say we have sine 45 degrees. Okay, we want to find the value for sine 45. So we would be looking at the green values and we look at which finger has 45 degrees. So it's this one, right? 45 degrees, and we need to look at the green value. Okay, so the value here is 2. So what are we going to do with the value of 2 here? So we are going to substitute it inside this value, square root n over 2. N here is the value that we have selected. Okay, so sine 45, it would be square root 2 over 2. Okay, so this is the hand method. We can actually find the value of the trigo functions with degrees of 0, 30, 45, 60 and 90, and we substitute inside to find out the value. Okay, so for this hand method, it only works for certain kind of angles. Yeah, it's only 0, 30, 45, 60 and 90, right? It doesn't apply to all angles. Alright, so now coming back to the cos 45 that we have here, so let's use this hand method to find out the angle. Alright, so cos is looking at the blue colors here, which starts from the y-axis. Okay, and then it's 45 degrees, so we need to look at the middle finger. Alright, so which is the value 2, right? Value 2. So the value 2, substitute inside this value, so it will be square root 2 over 2. Okay, and don't forget the negative, so the answer would be negative square root 2 over 2. So before we discuss the second part, I just want to explain what is special angles. Right? So special angles are all the angles that appeared in the hand method just now. 0, 30, 45, 60 and 90 degrees. Okay, so why they are called special is because by using the trigo functions and using these degrees, its answer can be very simplified, which is expressed in this fraction format. Okay, because for the other angles, it cannot be expressed in this way. For example, sine 75 degrees or sine 85 degrees. It cannot be expressed in the fraction format. Okay, so why these are called special angles is because they can be expressed in a very simplified way, which is in fractions. Alright, so let's go to the second part and let's use back the same method, which is the 360 degree A method. Alright, so the first part is to ensure the trigo value here satisfy the 4 criteria here. Alright, so for the first criteria is 3, which means the function must be from the 3 main trigo functions. So if we see here, the trigo function is cotangent, okay, which is not one of the 3 main trigo functions. So what we do is to change it to either tan, sine or cos. So we know that for cotangent is actually the inverse of tan, right? So we can change this cotangent to tan function. So here will be 1 over tan 5 over 3 pi. Okay, and with this, we have satisfied the first criteria. Alright, so let's go to the second criteria, which is the 6, which is P, which means positive. So the angle here is positive, so we have satisfied the second criteria. And now we can go to the third one, which is the 0 here, which means 1 cycle, which means the angle must be less than 2 pi, which we also see here. Okay, it is less than 2 pi, so we satisfied the third criteria. And for the last criteria, it must be in degrees, but here it's in radians. Okay, so we need to change this into degrees first. Okay, so how do we change it? Very simple, it's just multiply 180 degrees over pi. Okay, so once we've done that, the angle would be 300 degrees and we have satisfied the last criteria. Okay, so now we have satisfied all these 4 criteria and we can go to the second part of the method, which is the A, right? So for the 300 degrees here, we are going to change it to the acute degree, okay, by using the ASTC graph here, right? So we need to do 2 things again. So first thing first is we need to see for this 300 degrees, which quadrant does it belong to? Okay, so for this one, 300 should be at quadrant 4 or the section C. Okay, section C here. So we need to adjust the 300 degrees using this condition. So 306 degrees minus the degree that we have, which is 300, which is 60. Alright, so now the second thing that we need to do is we need to see this tan 300, is it positive or negative inside the quadrant or section C. Okay, so for section C, this means that for cos, it's the only trigo function that is positive. The rest of the trigo functions, which is sine and tan, they are both negative. Okay, so since we have tan, which means the value here is negative, right? So we do add a negative here. Okay, so for this one, now we can find the value of tan 60. Okay, but the issue is, here just now in part 1 we used the hand method, right? But if you see the trigo functions, we only use sine and cos. Alright, sine and cos. So let's transform this tan into sine and cos. Alright, so we know that tan is equal to sine over cos. Alright, and since this is inverted, means that 1 over tan is actually these two are inverted. We switch the places. So here will be cos over sine. Okay, so here we need to change it to cos over sine, which is something like this. Right, the negative still remains, but the tan we change it to cos over sine. So means we need to find the value for both functions, sine and cos, with the same degree. Okay, which means we are going to look at this finger here, and then we are going to use the 2 values, 3 and 1. Right, so for cos 60, we are going to use 1, so we substitute inside here. So here will become square root 1 over 2, and we know that square root 1 is actually 1, so we can change this to 1 first. Alright, and then the denominator here is sine 60, so we are going to use 3 and we substitute inside here to get square root 3 over 2. Okay, and don't forget the negative. Alright, so now we have the 2 values here. Let us simplify these 2 fractions without using a calculator. Alright, so here would be 1 over 2 and it's divided with a fraction square root 3 over 2, right? So as we know, fractions we cannot divide, we only can multiply, right? So we need to change from dividing to multiply. So means the numbers here, we need to switch their places. Okay, so above would be 2, below would be square root 3. And now you can see we can cross off the 2 here. So here will become negative 1 over square root 3. Okay, but for our values, for our final answer, it cannot have square root at the denominator. So what we are going to do is we are going to multiply its same value, which is square root 3. Right? So we know that for square roots, if we multiply itself, the square root will disappear. Okay, so denominator, it will be 3, and the numerator, which is 1 times square root 3, so here will be square root 3. Okay, and don't forget the negative. So our final answer would be negative square root 3 over 3. Alright, so before we go to the next part, I just want to explain this thing, which is why cos is the only function when there is negative angles, the negative will suddenly disappear. Alright, so let us focus on these 2 graphs, right? So for this graph, we will focus on the positive angles, and for this graph we will focus on the negative angles. Alright, so for the positive graph, the angles will flow in this way, right? So it starts with 0, followed by 90 degrees here, followed by 180 degrees here, and so on. So the flow of the angles would be something like this, right? For negative graph, for the negative angles, 0 will start at the same place, but for the next value, it would be here. Okay, so it goes the other way around. So 90 degrees, negative 90 degrees, it will be here. Okay, and then followed by here is negative 180 degrees, and then negative 270 degrees. So you can see that the flow is the opposite direction. Okay, so going to the bottom and then go to the top. Okay, so you can see that the flow of the angles, both of them are the opposite. Alright, and if we apply the ASTC here, right, so A will be starting at here for the positive graph, right, ASTC. But for here, it's the other way around also. So instead of A on top, they will start A at the bottom. So be ASTC. Okay, so now we have these 8 quadrants. Let us see for cos, is it positive or negative? So for A, because all of the functions are positive, so for the quadrants that have A, all will be positive. And also quadrants which have C, because C stands for cos, cos is the only function that is positive, so we are going to label it as positive also. So means for the rest of the quadrants, it will be negative, right? Okay, so now if we just ignore the flow, right, and we just focus on the quadrants here, okay, so if you look at the top left quadrant for both graphs, they have the same sign. For quadrant on the top right, it has the same sign. Same goes to here as well. Negative, here negative, positive, and positive. So if we use either one of the graph, the sign does not change. So this means for cos which have negative angles and for cos which has positive angles, these two values will have the same sign. So either both of them are positive or both of them are negative. So if we look at other functions, right, for example sine, okay, so for sine, A will be positive, right? S will be positive also, but for T and C it's negative, right? So let us use the same technique when we compare. So the top left quadrant, you can see it's positive A, here is negative. If here is positive, here is also negative. If here is negative, it's positive. If here is negative, here is positive. Right? You can see the signs are actually opposite of each other. Okay? Which is why we need to add a negative in front, because all of the signs are totally opposite from each other, from positive to negative. But the only exception is cos, because if we use either positive or the negative graph, they have the same sign. Okay, so this is why for cos, the negative can magically disappear. For the next part, we need to solve this trigo equation for the range of x from 0 to 2 pi. Okay, so if you see 2 pi basically is for our final answer later, we need to write it in radians. Okay, write it in radians, and it says that the answers that we need to give must be in terms of pi. So means that for the pi, we will remain it as it is. Let's not change them to 3.142. Alright, let's not change them. We just remain it as it is. Okay, so to solve this trigo function, if you see, there are actually two different kinds of trigo functions, sine and cos. Right, so usually I would recommend is to change all of these trigo functions to become the same function. So either is this sine will change to cos, or this cos will change to sine. Okay, so which one should we do? Well, we can look at the angle of the function. Okay, you can see that for sine, it's just x. So it will be a bit hard to transform it. But if you see here, the cos, there is 2x. So if there is 2x, it will be easier for us to change because we have a list of formulas from the formula sheet where the trigo function's value is 2a or 2x. Okay, which is from formula 32 to 34. We can use these formulas to help us change the functions that has 2x. Okay, so now it's cos 2x, so we are going to look at formula 33 and let's change this cos to be sine. Okay, so cos 2x is a bit headache because we have three different kinds of formulas. So let us see which formula has sine, okay, which is these two, right? So let's look at one by one. If we use this one, what will happen? Okay, so if we use this one, it will be a bit conflicting because if we change cos 2x to become this one, it still have cos. We want the entire equation here to be just sine. Okay, so since there's cos here, then we cannot use this one. We want to change everything to be sine only. So let's go to the next one. Okay, next one is 1 minus 2 sine square a or square x. Okay, so this one there is no cos, right? Which will be good for us, right? Because once we change cos 2x to become 1 minus 2 sine square x, everything here becomes sine only. Okay, so we have successfully changed all the functions to be just sine. So for the left side, I have multiplied the sine x into the bracket here, so it will become sine square x minus 2 sine x. Okay, so now let me move all of the things to the left side first. Okay, which means that this value and this value, because it has sine square x, it will be added up together. So here will be 3 sine square x. And for the negative 2 sine x here, no changes. The 1 here I move to the other side, so here will be negative 1 or minus 1. Alright, so if you see this equation closely, it is actually a quadratic equation. It's just that now the x is a trigo function, right? Sine x. Okay, because if you remove the sine, okay, and I move the square here, it's 3x squared minus 2x minus 1. It's actually a quadratic equation. So what we can do is we can use the factorization way by using the calculator. Alright, so when we find the two values of x, we need to make sure it is sine x, yeah? Sine x. We are not finding x, we are finding sine x, because now our x has the trigo function. Okay, so we need to write sine x here. So the two sine x values would be 1 and negative 1 over 3. Okay, so now from these two equations, we need to figure out the value of x. Alright, so for the first one, the value is 1. Okay, so this one we need to take note. If we see values that has negative 1, 0 or 1, okay, we need to take note because these values, the x values, cannot be found through calculator. It is found through our graph. Alright, so we need to recall back the sine graph. So sine graph is something like this, right? Where 1 would be here and negative 1 would be here. Okay, so now it's sine x equals to 1. So we need to look at the angle where the y value, right, the y-axis value, sorry, the y value is 1. Okay, so the angle here, what is it? Okay, so it starts from 0 and here is 180 degrees, right? So the middle here is 90 degrees. Okay, so for our x value, where sine x equals to 1, it will be this angle only. Okay, because for the entire line here, it only touches the sine graph at this point only. So the angle will be 90 degrees. Okay, so for values that has -1, 0, and 1, we need to use the graph way to find out the answer. Okay, so imagine, right, if let's say it's sine x equals to 0, and if we use calculator, there will only be one answer. But if you look at the graph here, when y is 0, you can see that there are 3 answers. 1, 2, and 3. 3 answers, which the calculator cannot find them. Okay, so we need to use the graph method to help us for this. Alright, for the second equation, we can use the ASTC method to help us, right? Because this value is not -1, 0, or 1. Alright, so this will be the ASTC graph. Alright, so we just need to do one thing. So according to this equation, where the sine value is a negative value, we need to see in this graph which quadrant is sine having a negative value. Alright, so A here stands for all, which means all of the functions here, their values would be positive. So which means it includes sine, and sine is positive here, so this is not the quadrant that we want. So we can go to the next one. So the next quadrant is S. S here refers to sine, and this means that sine is the only trigo function which is positive here, which is also not the quadrant that we want. We want sine is negative. Okay, so we go to the third quadrant, which is T, which stands for tan. So tan is the only positive trigo function here, which means sine is negative, right? Sine here is negative. So this is one of the quadrants that we want. Okay, and the last quadrant here is C. So C here is the only, C is cos. So cos is the only function that is positive, which also means that sine is negative. And this is also the quadrant that we want, right? So there will be 2 quadrants that satisfy the criteria here. And always take note, yeah, for this kind of equations, they will always have 2 answers. Alright, so our 2 answers here would be the quadrant 3 and quadrant 4, section T and section C. Okay, so now we have identified the quadrants that we want. So now we need to find the values based on the 2 conditions here. Okay, but first we need to figure out the theta value. So what is the theta value? Okay, so basically is for the sine, if we move it to the other side, what will be the value? Okay, so this one, it would be arc sine. Okay, so this is called arc sine, ARC sine. Okay, ARC sine. And for the value here, let us ignore the negative. Okay, so means arc sine 1/3 only. Ignore the negative. Alright, so once you put this into your calculator, you will see that the value is 19.47. Alright, 19.47. So we can just put this value inside here, the theta here, and to find the 2 values. Okay, so these would be our 2 answers for this equation. Okay, so now we need to go back to our question here, because here it says x must be within 0 to 2 pi, which means it must be in radians. Okay, so for all of the answers that we have gotten just now, we need to change it into radians. So what we need to do is, for each of the value here, we multiply pi over 180 degrees. Okay, but for this pi, again, let's not change it to 3.142. We remake it as it is. So means that for all of the values here, we just divide 180 only. Okay, so once we divide, these would be our answers. Okay, and let's combine all of the answers into one simple conclusion. Right, so x would be 0.5 pi, which is here. 1 over 2 is 0.5, and 1.1082 pi radians, and 1.8918 pi radians. Okay, so make sure when you change to radians, it is in 4 decimal places. Okay, so this is a standard answer for radians. It must be in 4 decimal places. Alright, moving on to the first question in section B, coming from differentiation. So here we have the curves equation, and in part A, we need to find out the coordinates of the stationary points. Alright, so let's recap back what is stationary points. Alright, so stationary points, we have 3 types. The first one is the minimum point, second one is the maximum point, and the third one is inflection point. Okay, so this one, it doesn't really come out in SPM, so let's take this opportunity to learn what is inflection point. Okay, so let's say we have this curve. Okay, so it goes down, and then somehow it is a horizontal line, and then it goes down again. Alright, so the inflection point would be at the horizontal line part. Okay, but you may ask, how do I identify that this point is an inflection point? Right, so we need to look at the similarities of these 3 points, which is dy over dx is equal to 0, or meaning the gradient of the tangent, which is m, must be 0. Okay, so coming back here, how do we identify this point is, we need to look at the gradient of the tangent, right? So gradient of the tangent here is, the tangent will be a horizontal line, right? A horizontal line. So here its gradient is 0. So basically this point is an inflection point, and its dy over dx is equal to 0. So now this is the similarity, but how do we differentiate them? Alright, so we need to look at the second level of differentiation, right? The second order of differentiation, d square y over dx square. So if the value, once we differentiate the equation twice, if it's greater than 0, then it will be the minimum point, lesser than 0 is the maximum point, and inflection point, it would be equal to 0. Alright, inflection point will be equal to 0. Alright, so now let's get back here. So to find out the stationary points, the similarity for all these 3 types of points is the dy over dx must be equal to 0. Right, so what we need to have is the dy over dx first. Then later on, we can change it into 0. Alright, so let's differentiate the curves equation. Okay, so before we differentiate, let us multiply this x squared into this bracket first, right, before we differentiate. Okay, so once we multiply, it will be 3x squared negative 2 over 3x cubed. Okay, so now let's differentiate them one by one, and what I will do before I differentiate is to separate these this thing by their minus and the plus, the negative and the positive. Right, so it would be something like this. So clearly I can see that we need to differentiate 3 things. Alright, so let's start off with the first one. So here I am going to copy the power in front, and then I'm going to minus 1 from the power. So here would be 2 times 3, which is 6, and the power would be 1. So here is just x.
Okay, so same goes to this one also. For the power, I am going to copy to the front, so means multiply with negative 2 over 3. So here will be negative 2, and the power here, I am going to minus 1. So here will be x squared. And for this one, it's just a number, so once we differentiate, it will become 0. So this means this will disappear. Okay, so now we have differentiated our equation. Okay, so now let's change the dy over dx to 0. Alright, so let us factorize the right side of the equation. Okay, so here let us look at the similarities of these two values. So one of the similarities is both of them have x, right? So I'm going to factorize an x out, which means I'm going to remove an x from both of these values. Okay, and then as you can see, these two values can be divided by 2, which means I can factorize a 2 out from these two values. Okay, so this means that these two values will be divided by 2. So this one will be 3 and this one will be 1. So 1 times x is still x, so this one can just disappear lah. Alright, so it's just x here. Okay, so once we factorize, it will be something like this. 2x and then 3 minus x. Alright, once we factorize, we can find out the two values of x already. So one is 2x equals to 0 and the other is 3 minus x equals to 0. And then we try to find our x values by changing the equation here and there. Alright, so our x values would be 0 and 3. Okay, so now we are trying to find the coordinates of the stationary points, right? So now we have the x coordinate already. So now we need to find out the y coordinate. Okay, so what we need to do, very simple. We are just going to use the x values that we have and then substitute inside the equation. Right, the curves equation. Okay, so if it's x equals to 0, so basically all the x will become 0 and we can find the y coordinate, which is 1 over 2. And when the x coordinate is 3, we use back the same equation here and then we can find out the y coordinate is 19 over 2. Alright, so we have the coordinates of our two stationary points and then we can write out a final answer for this part A. Alright, 0, 1 over 2, 3, 19 over 2. So for part B, it says hence we need to state whether each of the stationary points is a maximum or a minimum point. Okay, so coming back to our table here, it only asks maximum or minimum. So this means the second order differentiation value, it will be either more than 0 or less than 0. Okay, so inflection point, we can just ignore it first. Okay, so let us find out the equation of d square y over dx square first. Okay, because we need to find the value of this thing. Okay, so let us differentiate this equation again. Alright, so I'm going to separate them through the minus here. So means that we need to differentiate two things. Alright, so the same thing, the x values power here is 1. Alright, so 1 I move to the front, so 1 times 6 is still 6, and then I'm going to minus 1. So means that 1 minus 1 equals to 0, so x to the power of 0, which means this x will disappear. So it will just have 6. Okay, and using the same technique here also, so the power I'm going to copy to the front, so 2 times 2 will be 4, and the power I'm going to minus 1. So here will be just x only. Okay, so now we have the second order differentiated equation. Alright, so now let's substitute our x coordinates, the 0 and the 3, inside here, and to see whether they are more than 0 or less than 0. Okay, so once we substitute x equals to 0, we can see that the value is a positive value. So this means that this coordinate or this point is a minimum point. Alright, And for the other x value, which is x equals to 3, so once we substitute inside here, we can see that the value here is a negative value, right? Which means this point is a maximum point. But before we go to the next part, I would like to explain something at this equation, okay, before we differentiate. Alright, so this one, okay, if we straight differentiate, you can imagine that for this part, because there are two things multiply each other, when we differentiate, we need to use the product rule, right? So for this one, okay, for this one, when we differentiate, it would be u equals to x squared and v equals to 3 minus 2 over 3x, right? And then we need to separately differentiate it, right? For example, this one would be 2x, and this one will be negative 2 over 3. And then if you remember, it is cross multiplying, right? Okay, for this kind of steps, if we can avoid, would be the best, okay? Because here, the values, if we look at it, actually it's easy to multiply, right? Multiply to each other, then we can have a more simplified equation. So I will always advise students, if let's say you can multiply the values inside the bracket here, it will be the best. Because product rule, as you see, there's a lot of steps involved, right? You need to differentiate two things, and then you need to cross multiply and to make sure everything is correct, right? So if the things inside here, the things that you need to multiply, if it's not that difficult, please do so, alright? To prevent to do these kind of complex calculations, alright? And for part C, here it says if x increase from 2 to 2.01, we need to figure out the approximate value in y. Okay, so this question means that if we increase slightly of x from 2 to 2.01, of course the y value will change, right? So the approximate value here means what is the final value of y once we change the x from 2 to 2.01. Right? So you may be asking, teacher, if we want to find the final value of y, shouldn't it be 2.01 and then we just straight substitute inside this equation and find the value of y? Okay, so yes, you are right. We can actually substitute this value inside here to get the value of y, but here you notice it says the approximate value of y. So it's not the exact value, but a approximate value for y, an estimated value of y. So we cannot just substitute 2.01 straight inside here. Okay, so let me give you an example here. So let's say we have another equation. Let's say it's y equals to 1 over x, and then the question says if x increase from, okay, let's say negative 0.1 to 0. Okay, so let's say we use the same technique. 2.01, just now we say we straight substitute inside here, right? So let's say this 0, I also straight substitute inside here. Okay, but if you notice, we cannot find the value of y because when we substitute 0 into x, it's 1 over 0, which is undefined. Alright, so for this kind of cases, then we need to find out the approximate value of y, because here there is no exact value of y, there's only approximate value of y. Okay, which is why here we need to learn how do we figure out the approximate value in y. Okay, so it's not the exact value, but the approximate value. Okay, so this is the last application in differentiation, which is called small changes and approximation. So it teaches us how do we find the approximate value by using differentiation. Okay, so here, how do we find the approximate value is, so firstly, we need to have the original value of y, right? Okay,
And then since x changed slightly, we also need to see how much did y change, right? So it would be the small changes in y. So if we have the original value of y and the small change, okay, the small change in y, then we can figure out the approximate value. Okay, so you may be asking, how are we going to find the original y and the small change in y? Okay, so here in this application, it has two formulas and we need to understand them. Alright, so for the first formula, it's delta y. Okay, so this symbol is called delta, D-E-L-T-A. So delta y over delta x approximately equal to dy over dx, which we have seen just now. Okay, the differentiated equation of y. Alright, so what is delta y and delta x? So basically, delta y is the small change in y, and delta x here is the small change in x. Okay, so coming back here, we are trying to find delta y, right? Because again, delta y is the small change in y. So let me give you an example what is small change. Okay, so let's go back to here. Alright, it says that x increased from 2 to 2.01, so means there is a small change in x, right? So if we want to figure out the small change in x, which is the delta x, so here would be 2.01 minus 2, right? Which is 0.01. Okay, so our small change is positive 0.01. So 2, I add 0.01, then I will get 2.01. Okay, so delta x is 0.01. And it's our small change in x. Okay, so this is for the first formula. And for the second formula, it's the percentage change in y. So if you want to figure out how much did it change based on the percentage format, it will be delta y. Okay, so these two things are the same, which is a small change in y. And below here, it will be divided with y. So y here is the original value of y. Okay, and then we need to multiply 100%. So this is the second formula. But as you can see in this question, it does not mention percentage. So technically, we don't need to use this formula for this question. Alright. So now coming back here, how do we find the original y and how do we find the small change in y? Okay, so let's focus on small change in y first. So to find this, we can use back the first formula. Alright. Oopsie, sorry. Let me erase this part a bit first. Alright, so since we are finding delta y, then we need to do some changes in this formula. Okay, so let me move this delta x to the other side. Alright, because we are finding delta y, right? So here the delta x will become multiply delta x. Okay, so if you want to find delta y, it will be approximately equal to dy over dx times delta x. Okay, so to find delta y, we need to have these two things, dy over dx and delta x. Alright, so for dy over dx, we already found it in part A and part B just now, which is this. Okay, this result. So let us substitute this result into here. Okay, and just now we have also found out delta x, which is 2.01 minus 2. Okay, but if you see here, there are x, the unknown x here. And as we know, this delta y, which is the small change in y, cannot have unknowns inside. It must be a value, right? So for this x, we need to change it to a value. But what value? Right? So for the x value, we can just use the original value of x, okay, which is 2.
okay, we can just use the original value of x and we substitute inside here. Okay, so for all the x, it will become 2. Alright, and once we simplify this, this will be our small change in y, which is 0.04. So means that if we increase the x by 0.01, y will increase by 0.04. Okay, so now we have found out the small change already, so we need to figure out the original value of y. Okay, so how do we do this? So basically, we just need to have the original value of x, right, which is 2, and I just substitute inside this equation, and then I can get the original value of y already, right? So x equals to 2, substitute inside the equation, then I can find out the original value of y, which is 43/6. So I can put it here. Alright, so now I have the original value of y and the small change in y. I can add them up together, then this would be the approximate value, 1081/150, or you can write it in the decimal format, which is 7.207. Next question, we are going back into circular measure, and in part A, there's a few information given here, so let me explain them using this diagram here. Alright, so here we have two sectors, which is the small sector here, which is the sector OUV, right, OUV, and the big sector, which is OST. Okay, so each of these sectors are coming from different circles, but the center of the circles are the same, which is O. Okay, both of the center of both of the circles or both of the sectors, the center is O. Alright, and it also gives us the ratio of these two shapes. Right, so the area of the sector OUV, which is this small sector here, it has one part, and the area of the shaded region, which is this region SUVT, it has 8 parts. Alright, 8 parts. And it also says that OU is 4 cm, which is this line, which is actually the radius of this small sector, right? Because it connects to the center O. Okay, and it also gives us the area of the sector OUV, which is 6 cm square. Alright, so in part 1, we need to figure out the angle SOT in radians. Right, so the angle SOT is here. Right, and then we need to figure out the value of the angle here. So this angle SOT is also actually part of the small sector, right? UOV, right? So SOT and UOV is actually the same, right? And since for this sector, it already gave us the area of sector, and we know that the area of sector, inside the formula, there is theta, right? The angle of the sector, right? So let's pull down the formulas, right? So you can see that for formula 28, the area of sector formula is A equals to 1/2 r squared theta, right? The angle of the sector. So since we already have the area of the sector, and we have the radius of the sector, which is 4 cm, so why not we use this formula to find out the theta. Okay, so let us use this formula. So area of sector OUV will be equal to 1/2 times the radius of the sector, which is 4, and then we are going to square it, and we are going to multiply with the angle that we are trying to find, angle SOT. Okay, so now let us substitute the area of sector OUV, which is the small sector's area, which is 6, into the equation here. And to find out the angle, we just move these two values to the other side, meaning dividing with 6, then we can find out the
angle, which is 0.75 radians. Right, so just to recall, for formulas 27 and 28, the theta here is in radians. Okay, is in radians. The other formulas that has angles, all of them are in degrees. Okay, only these two formulas uses radians. Alright, so now let's go to the second part. We need to find out the length of SU. Okay, so let me change the color of the pen. So in this diagram here, the line SU would be here. And if we want to find out its length, it will be best for us if we have the length of the entire line here, right? Which is the line SO, right? Reason is because if we have the length of this line, we can minus with 4 and then to find out the length of SU. Alright, so this is what we need to do to find out the length of SU. Firstly, we need to find out the length of SO. Alright, and if you notice, this line here is the radius of the sector here. Radius of sector OST. Alright, so how do we find out the radius? Right, so actually we can look at the formulas here. Okay, and since there are two formulas, means there are two ways to find out the radius. Right, so if you look at the formulas, you can see that both of them use radius to find out the arc length and the area of sector. So depends on our question here, if we have the arc length or the area of sector, we can use them to find back R. Alright, by using these two ways. One way is the arc length and the other way is area of sector. So let's start off with the first way, which is the arc length. But if you see in this diagram, we don't have any information that is related to arc length. Okay, so this means we cannot use the first way. But let's see if we can use the second way, area of sector. Right, so here we also don't have the area of sector OST, but if you see in the question, they gave us the ratio of the areas of these two regions, sector OUV and the shaded region here. Right, so the small sector is 1 part and the shaded region is 8 parts. And if you notice, if we add up the area of these two regions, right, which is the area of the small sector here and the area of the shaded region here, it is actually the area of the big sector here, right? The area of sector OST. So we can actually find out the area of the sector OST. Right? So to find out the length of SO, we can find out the area of sector OST first. Alright, so since sector OST is made up of these two regions and each of the regions here have their own parts, which is 1 and 8, so means that sector OST has 9 parts. So we just need to figure out how much of area is for one part, which is also given in the question. Right? Because the small sector's area is only 1 part and it also gave the area of the sector, which is 6. So 1 part is 6 cm square. So for 9 parts, it would be 9 times 6, right? 9 times 6. Okay, so let's write out the workings. So area of sector OST, it would be 6. 6 is the area of the sector OUV times 9. Right? Which is also 6 times 9, which would be 54 cm square. Alright, so we have found out the area of sector already. So let's find out the length of SO by using the area of the sector formula here. Alright, so here would be 1 over 2 times the radius of the sector, which is what we are trying to find now,
right? SO, and don't forget the square here. And then we are going to multiply the angle of the sector here, which is theta, which is the answer that we have gotten in part A1 just now, which is 0.75. Okay, so what I need to do here is to move these two things to the other side and divide with 54. And once we have the final value, we need to move the square to the other side. So the final answer here, it will have a square root, and then it will have plus and minus here. Okay, but since here we are just finding the radius, alright, and radius is actually a length, and length cannot be negative, right? It must be a positive value. So for the square root here, what we are going to do is we are going to ignore the negative version. Okay, because we don't have a negative length, we don't have a negative radius. Okay, so once we move the square root, we will get the length of SO is 12 cm, right? So now we have also found out the length of SO. So now to find out the length of SU, it will be just 12 cm minus out 4 cm. Okay, so SU would be SO, which is the length of the entire line here, minus out this small part here, which is UO, right? So it's 12 minus 4, then would be 8 cm. And for part B, we have a piece of the fan-shaped paper which is shaded in this diagram here, which is the region ABCD, right? And this fan-shaped paper is part of the sector here, right? Part of the sector here with the center O. Alright, so here we are given a few information, so let us go through one by one. Alright, so the angle COD, so angle COD is here, and the angle here is 2.65 radians. Alright, so we do take note that this angle is in radians already. Alright, and for the second part, they gave us the ratio of OB and BC, which is these two lines. Okay, so to figure out the ratio, let me do some adjustments in this equation. Okay, so for left side, I'm going to remain OB on the left side, but I'm going to move BC to the left side. Okay, so here will be divided by BC. Okay, and the right side of the equation, I'm going to put 2 here because the right side there is 2. And I'm going to move 3 to the other side. So here will be divided by 3. So why I do this is because you can clearly see that OB has 2 parts and BC has 3 parts. Okay, so this is one of the ways that I can share to y'all when we are trying to find the ratio of these 2 lines. Okay, and for the last information here, it says that OC is 30 cm. So OC here is the radius of the sector, which in this sector, OD is also the radius of the sector, right? So both of them are 30 cm. Okay, so in part 1, we need to figure out the area of the fan-shaped paper, which is this region ABCD. Okay, area of the shaded region. So in the previous questions, we have also I also shared the method to find out the area of the shaded region, right? Which is these 2 methods: big shape minus small shape, or add up all the shapes. So for this one, I would say we will also use the first method, right? Big shape minus out the small shape. Okay, so again, big shape would be the shape that we include the area that we want, right? Which is this shaded region here. And it must be a recognizable shape. So here, our big shape would be the entire sector, right? Because it includes the area that we want. So this would be the area of sector ODC. Okay, and now for the small shape would be the shape that we need to remove from the big shape because we don't want it.
So here, the small shape would be this part, right? Because this part is not shaded, means that we do not want it, right? So the small shape would be this small sector here. Alright, so to find out the area of shaded region, it would be the big shape, which is the area of sector ODC. Oh, sorry, this should be area ODC, and minus off with the small sector, the area of the sector OAB. Okay, so we are going to use back the formula area of sector, and then we minus these two values to find the area of the fan-shaped paper. Alright, so let's start off with finding the area of sector ODC first. So 1 over 2 times the radius of the sector here, which is 30. Alright, 30, and I'm going to put a square here and multiply with the theta here, the angle here, which is given 2.65. Alright, and for the area of the small sector OAB, same thing as well, minus 1 over 2. And for the radius of the small sector OAB, we do not have the value yet, so let us find it out first. So the radius of the small sector would be here, and here we do know that it has 2 parts. Okay, so here the entire line here is OC and it has 5 parts, and we do know the length of it, which is 30 cm, right? Because this is the radius of the sector here. Okay, so if we want to find the length of 2 parts only, very simple, it's just 30 divide with the total parts here, which is 5, and multiply with 2, right? So here would be 30, I multiply with 2 and divide by 5 to get the radius of the small sector here. Okay, and don't forget to put the square here, and we are going to use the same angle, which is 2.65. So once we put this into a calculator, we can figure out the value, which is 1001.7 cm square. And for the next part here, it says we need to find out the maximum number of the fan-shaped paper if we have a piece of paper with an area of 8000 cm square. Okay, so this is the total area of paper that we have, and we need to see how many fan-shaped paper can we do. Okay, so this one, to find out the number, it's just using the total area of papers that we have, which is 8000, and we divide by the area required to do one fan-shaped paper, which is our answer in part 1 just now, 1001.7. Okay, so we are just going to divide these two values to find out the number of fan-shaped paper, right? So the total area of paper that we have divided with the area of paper that we need to make one fan-shaped paper. So it will be this value. Okay, and for this value we cannot round up, meaning the answer would be 8. Okay, it cannot be 8. Okay, reason is because if I split the value by the decimal point here, so there will be 7 fan-shaped papers. But how about here? Here is 0.9864 fan-shaped paper, which is not actually one fan-shaped paper. It's actually just part of the fan-shaped paper, right? So means for this paper there will be a part is missing. So if there's a part missing, this means it is not a fan-shaped paper, right? So our answer here would be just 7 only. Okay, it wouldn't be 8, it would be 7, because here we only have 0.9864, which is not enough to do one fan-shaped paper. Alright, so our answer here would be 7, not 8. And for the last question, going back into quadratic functions. So here we are given a quadratic function, and it is given its minimum point, which is 1 and negative 7. Right? So in part A, we need to figure out the value of n and p from this quadratic function. Alright? So here, since it has given the minimum point already, so why not we try using the function given here to find out its minimum point first. Right? So once we have found out the minimum point from this function, and then we compare it with the given minimum point to find out the value of n and p. Okay, so what we need to do now is to find the minimum point from this function. But how do we do that? Alright, so what we need to do first is to change the form of this function. Right? So recall back the things that we learned in this chapter. In order to find the minimum point from this function, first we need to change the form from this form to become the vertex form. Right? Which is this format. F of x equals to a bracket x minus h bracket square plus k. Right? So why we need to use the vertex form is to find out the minimum point. And from this vertex form, the minimum point or the maximum point is these two values. Alright? So the minimum or the maximum value is hk. But how do we change the form that we have now, which is this one? Okay, so this form has a name. It's called the general form. Alright, general form of the quadratic function here. How do we change it to vertex form? So we need to use the completing the square method. Alright, so we need to use the completing the square method in this general form to transform it into the vertex format. Right, and we need to follow these 3 steps. Right, so the first step is to factorize. So what are we factorize? Alright, so for the values that has x, which is these two, I am going to factorize these two values according to the value of x squared, which is 2. So means I am going to take out 2, alright, the value 2 from these two values that has x. Okay, so it will be something like this. Right? So for the 2x squared here, I'm going to take the 2 out, so it will be left with x squared only. And for the other one, since I want to take out a 2 from here, so means I need to divide 2 with this value here. So it's negative n over 2x. Right? Because I take out a 2 from here, which means I need to divide this value with 2. Okay? And for the value that does not have x, we would remain it as it is, right? Which is the p here. Okay, so this is for the first step. So now, the second step is to divide and square. Okay, so means that I will be using the value of x, which is negative n over 2, to add and minus something at the back. Okay, so what I'm going to do is I'm going to add the value of x, which is negative n over 2, and I divide with 2 and I square this value. Right? So it will be negative n over 2 and square it. Okay, so since I add this value already, I need to balance the equation, right? So when I add something, I need to minus something also. So at the back here, I'm going to minus the exact same number. Right? But here it's just negative only, or we need to minus. Alright? And don't forget the value of p at the back. So this is the second step. We need to divide and square according to the value of x, which is negative n over 2. And now we are going to the last step, which is to combine. So what are we combining? So here we are going to look at the first 3 values here, and we are going to combine these 3 values by taking the values that has square. right, which is the x squared here and this value here. Okay, so means I'm going to take out the value of x here and the value here, which is negative n over 2 over 2, which would be negative n over 4. Alright, and I'm going to remain their square at the outside of the bracket. Okay, so these three values have been combined into this value. So until this part, we have actually used the completing the square method already. So for the rest of the steps here is just to simplify the equation. Alright, so for example for this one, let us simplify it. So negative n over 2 over 2 here would be negative n over 4. Alright, inside the bracket. And don't forget there's a square outside, so we're going to square all of the values inside. So if negative I square, it will be negative negative positive, right? And the n here, if I square, it will be n square. If the 4 I square, it would be 16. Okay, so inside the bracket it would be n square over 16, and don't forget the negative outside. Alright, so here will be negative n square over 16. Okay, and don't forget the p at the outside of the bracket. And now, to simplify even further, I'm going to multiply the 2 inside the bracket into these two values. Right? So the first value would be 2 bracket x minus n over 4 square, and the other one would be just multiply with 2, so here will be negative n square over 8, and the p remains the same. Okay, so now we have successfully changed the quadratic function from the general form to the vertex form. Alright, so now we need to figure out the value of h and k from here. Right, so h would be the value inside the bracket here, which is n over 4. Alright, n over 4. And the value of k would be the values outside of the bracket here, right? Which is this entire thing. Okay, so this entire thing is value of k. But just to let you know this very important thing, right? So if you look at the value of h that we have found just now, it is actually n over 4, right? But actually it is a negative value. Right? Before it was negative value, negative n over 4. But you see, when we extract it out, the negative disappears. Okay, so this is a thing that which is very important. So when you extract the value of h out, if it's a negative value, when you extract, it must change to a positive value. Right? Negative change to positive. But if let's say the value inside the bracket here, it's positive n over 4, and you want to find out the value of h. Alright, so this positive value, when you want to find the value of h, it must change to negative. Okay, so take note, yeah, when we are trying to find the value of h, negative value need to become positive. Positive values need to become negative. Okay, so now we have the minimum point from our quadratic function already, so let us compare with the minimum point that is given here, which is 1 and negative 7. Right, so for the value of h, which is n over 4, we equal with 1. Right, so let me write here, n over 4 equals to 1, so here will be n equals to 4. Right, and for the k part here, which is negative n squared over 8 plus p, this one will equal with negative 7. So we know that n is equals to 4, and if I substitute inside here, it will be this result, and I'm going to move this part to the right side to find the value of p. So this value will become positive once we move to the other side, and we minus with 7. So the p value here is negative 5. But before we go to part B, I just want to share another way of solving this question, but it does not have any relation with quadratic function, right? It relates to another chapter that also uses minimum point to solve questions, right? So can you guess it is from which chapter? So it's actually the Form 5 chapter 2, which is differentiation, right? So in the previous question just now, we have also said that for minimum points in differentiation, their dy over dx is equal to 0. Alright, so what we are going to do is we can use dy over dx equals to 0 and to find out the value of n and p here. Okay, so dy over dx again is the differentiated original equation. So here we have a function, so it's the same thing also. We are going to find the differentiated function. Okay, so instead of writing dy over dx, for functions there is also another way, which is f prime x. Okay, so this is a notation for functions once we differentiate the first time. Okay, so dy over dx and f prime x is the same, right? Same meaning. Okay, so now how do we find out f prime x? So we are going to differentiate the things here one by one, right? So again, I am going to separate this function based on their based on their minus and the plus. Okay, so here we need to differentiate three things, 1, 2, and 3. Right, so to differentiate again, I need to copy the power to the front, so meaning multiply with 2, so 2 with 2 it will be 4. Alright, and then the power here I minus 1, so here will be just x only, and the power here is 1. Okay, here the second one, there is just x only, so I'm just going to extract the value out, which is negative n. And the p here, okay, p here is actually a value, alright? So as we know, if we differentiate values, it will disappear or it will become 0. So this one we can just ignore. So our differentiated function would be 4x minus n. Okay, so since we are finding the minimum point, alright, we are finding the minimum point, so the f prime x here would be 0. So on the left side here, this would become 0. And now we need to figure out the value of n, right? So the value of x here, we can just use the x coordinate from the minimum point here, which is 1. Okay, so I'm going to substitute 1 here, and then I rearrange the equation here and there, and I can get the value of n, which is 4, which is same as the first method that we did just now. Okay, so once we have the value of n already, and we have the coordinates of the minimum point, so why not we use all of these values to substitute inside here the original function to find out the value of p. Okay, so here I substituted the value of n, which is 4. So now I substitute the coordinates of the minimum point, which is 1 inside x, and this x here, and negative 7 inside here, which is f of x, which is also y. Okay, so once I substitute everything, then the value of p here would be negative 5, which is again the same answer that we have gotten in the first method as well. Okay, which is here. Alright, so you may be asking, if I compare these two methods, which one would be the best one? Okay, so of course, based on the workings that we have written down, you can see that differentiation is much shorter. Alright, so means it will be faster. So if you are going to the, I would say, the faster route, I would recommend the differentiation way. But in some certain questions, they will state that for this type of question, yeah, in quadratic functions, it will say that you cannot use the differentiation way, right? Meaning you cannot use the things that we have learned in differentiation to solve the question here, right? So some SPM questions will say that, right? So not all the time we can use the differentiation way. So what I would recommend is, to play safe, we just use the completing the square method. Okay, because completing the square method, it's from this chapter, right? Quadratic functions, so it can be applied to all questions which is similar to this. Okay, so yeah, so this is the risk lah. If you want to use the differentiation way, of course it's faster, but it's not all the time that we can use. Completing the square method, 100% of the time can use. Okay, so personally, I would recommend is to use the completing the square method to avoid losing marks. And for part B, we need to sketch the graph of the same function f of x. Alright, so if you look at the function here, just now in part A, we already found the value of n and p, right? So n here is 4 and p here is negative 5. So this would be our function of f of x. Alright, so just now we have also mentioned the form of this function, which is also called the general form, right? The general form. And before we draw the graph of this function, we first need to understand each of the things in the general form, which is a, b, and c. What does a, b, and c here mean? And how does it affect our graph? Alright, and also just now in part A, we also used the completing the square method, right, to change this general form to become the vertex form. Alright, so inside the vertex form, we also need to understand what does A, H, and K mean, and how does it affect our graph. Okay, so we need to look at all of these values to see how do we draw out our graph. So let's go through one by one. Alright, so A here represents the shape of the graph, and we only have two types, right? So if A is greater than 0, we have a smiley face graph. If A is less than 0, then we will have a sad face graph, right? So now, according to our value of A here, it's 2, so means that when we are drawing the graph, it would be a smiley face graph. Alright, and now going into B. So B here represents the position of the minimum or maximum point. Okay, so this one will be a bit tricky. So, okay, reason is because it depends on the value of A also. Alright, so if A and B, they have the same sign, right? So sign meaning either both A and B are positive or both A and B are negative. So if that's the case, then the minimum or maximum point will be at the left side of the y-axis, right? The left side of the y-axis. If A and B are different signs, meaning A is positive, B is negative, or A is negative, B is positive, so the minimum or maximum point would be on the right side of the y-axis. Okay, so if we look at the value of A and B now, A is positive, B is negative. So this means that our position of the minimum or maximum point would be on the right side of the y-axis. Okay, so we will be using this. Okay, and the last one, C. So C here is the y-intercept. Okay, so our y-intercept would be -5.
Alright, so when we are drawing the graph, we need to ensure these things are fulfilled. Right, so the first thing is we are drawing a smiley face graph. The position of our minimum point, because it's a smiley graph, so it will have a minimum point, okay, which is also said in the question also, right? So the minimum point will be at the right side of the y-axis, and then for the y-intercept, we need to show that it is -5. Alright, so now let's go to the vertex form. So vertex form, the first thing here is the A. So the A here and the A at the general form, both of them are actually the same thing. They are describing the same thing, so it's also the shape of the graph. And for H, it's called the axis of symmetry, or meaning the middle line of the curve. Okay, so means here we have this curve, and the middle line of the curve here will be this line. So this line is called the axis of symmetry. Okay, and here we are given the minimum point, right, which is 1 and -7. So this axis of symmetry actually intersects the minimum point. Okay, so usually the minimum point will be here, and the axis of symmetry will intersect it. Alright, so the equation of the axis of symmetry would be the x coordinate of the minimum point, which is x equals to 1. Right? It cannot be 1, yeah? The axis of symmetry is not 1, because axis of symmetry is a line. Right? It's a line. So we cannot write it as 1, we need to write it as a line equation, which is x equal to 1. Alright? So the axis of symmetry is the middle line of the curve. Right? And it touches the minimum point. Okay, so how about K? K here is the minimum or maximum value, or it actually means the y coordinate of the minimum point, okay, which is here, -7. But for H and K, you don't have to worry that, for example, oh, the axis of symmetry must be this line, and the minimum or maximum value must be this value. Okay, actually you don't need, because we know that if we combine H and K, right, H and K is actually the minimum or the maximum point, right? So when we are drawing the graph, we just need to make sure we label the minimum or maximum point, which is here, 1 and -7. Okay, so later when we are drawing the graph, we just need to make sure that we label the minimum point, okay, which is 1 and -7. Okay, so now we have understood all of the unknowns in the general form and the vertex form. Okay, so now let's draw the graph. Alright, so to draw the graph, firstly what I will do is I will draw the shape of the graph first, okay, before I do anything. So we know that our graph is a smiley face, right? So I'm going to draw a smiley face here first. And then we are going to plot the points that we have. For example, the minimum point, right? So we know that the minimum point is actually at the middle line of the graph, or the axis of symmetry. So I'm going to plot the minimum point here. Alright, and I'm going to label the coordinates, which is 1 and -7. So now, according to the coordinates of the minimum point, I am going to draw out the x-axis and the y-axis. Okay, so since the x coordinate is 1, so means it would be on the right hand side of the y-axis, and since it is 1, which the value is small, so it will be closer to the y-axis. Okay, and for the y coordinate here, because it's negative, so it would be below the x-axis, but here there's a huge gap, right, -7 and 0, so it will be further away from x-axis. Okay, so my sequence would be draw the graph, plot the points, and then draw the axis. Okay, but you may be asking, why do you do this? Because, alright, let's say we follow this sequence, we draw the axis first, then we draw the graph.
right? But sometimes when we are drawing the graph, it might not be the graph that we want, right? So for example, it would be something like this. You can see here, right, it's not that curved. So we might, okay, we need to rub off the entire graph again, and then we need to redraw. Okay, so when we rub off the axis as well, right? Because when we're drawing the graphs, we can only use pencil, we cannot use pen, right? So you rub off the entire thing, and then you need to redraw the x-axis, and then you need to redraw again, and then you see, it's not the shape that I want again, then I have to rub off and redraw again. So you can see the entire process, it's very time consuming, right, for drawing just one graph. So what I would prefer is, firstly, draw the graph first. Okay, because if you didn't really draw the graph that you want, you can still rub off from this blank space and then redraw again, right? Then later on, you plot the points. Then later on, from the points, you draw the x and the y axis. Okay, so it will be faster and you don't need to waste a lot of time to just draw one graph. Okay, so this will be our graph, but we need to double check whether all of the things here are fulfilled from these values here, the A, B, C and the A, H, K here, right? So A, again, our graph must be a smiley face. Okay, so here we have a smiley face already. And for B, our position of the minimum point must be at the right side of the y-axis, which is true because it is at the right side of the y-axis. Okay, and the y-intercept. Okay, so I think we need to label the y-intercept here. So the y-intercept is here, and we need to label -5. Alright, and for the vertex form for A is the same thing as the general form A, so we can just ignore. H and K is actually the minimum or maximum point, which is already here. Okay, so we have fulfilled all of the conditions here, and this would be our graph. But before we go to the next part, you may be asking, hey teacher, because our graph already intersected the x-axis, shouldn't we also label these two parts the x-intercepts? So I asked this question myself also, so I went to find the x-intercepts. So what I did is I used the factorization way using the calculator to figure out the x values, right, which would be the x-intercepts. So I inserted the A, B and C values, which is 2, -4 and -5. So when I press enter, I saw that the x-intercepts is not that simple as it seems, right? Because you see the answer here, there is square root. And in the previous question, we have mentioned that if there is square root, we cannot just simply put the x-intercept onto our answer sheet, right? We need to show how did we calculate the value of the square root. Okay, so you can imagine that there will be a lot of steps to find the x-intercepts, right? Which we need to use the quadratic formula, right? But if you see here, it's only 2 marks. So most likely the x-intercepts won't have any marks because the marks are already given to the -5 here, the minimum point here, the shape of your graph, and also how you label the x-axis and the y-axis, and also the conditions that we have seen just now, the A, B and C and the H and K. Right? So this one depends on the marks. If let's say here there's a lot, means that we need to find the x-intercepts according to the using the quadratic formula. Okay, so this depends on the question itself. If you see less marks, then most likely we don't need to do that. And for the last part, here we need to find out the range of values of h if the function f of x equals to h has 2 distinct roots, right? 2 distinct roots. So here, if you see there is range, means that in our final answer, there will be inequalities. So it's like the greater than and the less than that we see all the time, right? So in our answers, they will have these symbols, these inequalities. And here it says two distinct roots, right? So in the previous question, we also have this similar question also. So if we see roots, so means we need to relate it to the discriminant. So the discriminant is this one, b squared negative 4ac. Alright, and we do know for discriminant there will be three types. Alright, so one is greater than 0, one is equal to 0, and one is less than 0. Okay, and they have their own conditions to decide whether it's greater, equal, or less than 0. Alright, so here in the question it says two distinct roots, meaning two different values of x. So which one will it be? Okay, so I give you a 5 seconds to think about the answer. Right, and the answer is this one, right? Because two distinct roots means that we have two x values, and if we have two x values, means the graph will touch the x-axis at 2 points. Okay, so this is the discriminant that we need to use, b squared negative 4ac greater than 0. Alright, so now we need to figure out what is the value of b, a, and c from this equation. Okay, so let's start off with f of x equals to h, and let's substitute the function that we have gotten just now, 2x squared negative 4x negative 5. Okay, so here what I'm going to do is I'm going to move h to the other side. Alright, move h to the other side to see what is the value of a, b, and c. Okay, so the value of a would be the value of x squared, which is 2. Value of b would be the value of x, which is negative 4. And c would be the value that does not have x, so includes the h here. Alright, so for this kind of questions, we need to ensure that the right side is 0, meaning there is nothing on the right side. Everything has moved to the left side to see what is the value of a, b, and c. Okay, so let me substitute the values according to the color here. Alright, so b will be negative 4, a will be 2, c will be negative 5, negative h. Right, so if we simplify the left side of this inequality, so here will be 16, and here, which is actually negative 4 times 2, which is negative 8. Negative 8 multiplied with the things inside here, so it would be positive 40, positive 8h. Alright, so now we need to find the range of values of h. So h we need to remain on the left side, the rest of the things move to the right side. Okay, so 40 and 16 will move to the right side, so here would be negative 56, and then I move this 8 to the other side, so it's divided by 8, so negative 56 divided by 8, here would be negative 7, and this would be our final answer, h greater than negative 7. And with that, we have completed the discussion of this paper. Alright, so thank you so much for watching this video. If you have any questions regarding the discussion here, feel free to put your questions in the comment section below. Right, I try my best to answer them as soon as possible. Okay, so for the next discussion video, I'm still thinking whether should I do Sabah paper 2 or another state paper 1. So I'm still deciding on that, so I'll let you all know once I have the decision. Okay, and also I would like to say this for all the videos that I've done this year, which is I know SPM is going to be happening in these few weeks, right? So I want to let you all know that your health is very important. Alright, so because without good health, how are you going to get good grades in SPM later? Okay, so I'm not talking about physical health, I'm talking about mental health as well. Alright, so please prioritize your health during these few weeks in SPM lah. Okay, so thank you so much for your watching this video again. I hope you learned lots of it from this video. Right, so take care and I'll see y'all in the next video. Bye bye.